Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello everyone, I welcome you all to India's largest e-learning platform, Unacademy. I welcome you all to GATE Conqueror channel. As a part of BARC Marathon series, this is Marathon Part 5 today, and I start with EMF today. Myself, Sathish Reddy, I have 12 plus years of teaching experience in teaching, guiding and mentoring GATE and ESE aspirants. Subjects of expertise, EMFT, communications and advanced communications. And if you are a serious aspirant, I recommend you to take a plus subscription where you get a lot of features and for your preparation. And if you can use the code GCR10, you will get 10% discount for the same. This is the plus subscription I was talking about. In plus subscription, you get the face time of legendary faculties in the form of live classes. You have crash courses. You have weekly tests. Tests are very important. Test is a very important parameter for your preparation. So weekly tests you will have so that you will understand your level of preparation. Doubt solving, and it will be instructed both in Hindi and English. And there is a rank improvement batch also as a part of plus subscription. And the iconic subscription include all of this along with the personal coach for you for solving your doubts on day-to-day basis and also for your career guidance. Dedicated doubt clearing instructors. You have a personal coach for helping you out in preparation strategies. So all this along with the standardized material in iconic subscription. What not? Iconic will have everything. This is a subscription value after 10% discount after you use the code GCR10. Yes, Arpit Singh. Good afternoon. Once you use the code GCR10, you get this for the subscription value of 29,205 for 12 months. 37,170 for 18 months and 42,480 for 24 months. This is what you get for the plus subscription. And iconic subscription you get for 12 months, 18 months and 24 months for the subscription value of 45,000, 58,000 and 66,000. And also you have a no cost CMI facility for the same. Yes, Venkatesh, Nandesh, Krishna. Good afternoon everyone. You have this Unacademy Ask a Doubt. We have this Ask a Doubt concept where you can ask unlimited number of doubts through that particular channel. So this is a very important update from Unacademy, and this is the, I can say Unacademy is the only platform which gives you like this facility like this, where you have Ask a Doubt facility. You can ask any doubt and that particular doubt will be resolved. So that's a very beautiful platform. Vandala, good afternoon. And these are the new batches. Mainly we have the new batches for GATE and ESE for GATE 2022 and 2023 and ESE 2022 and 2023. The main batches are the Crack GATE 2022-2023 and Arohan GATE 2022 and GATE 2023. Along with that, there is a target batch in which we cover the subjects which are not common for GATE syllabus. These are the features of the special classes that we conduct on Unacademy app. The special classes includes interactive live classes, polls for the learners, raise a hand option. There's a new option that we have, raise a hand, where you can ask your doubts, and never miss a class. Once you on your notification, you'll get your lecture notes, and also you can access it at any time and anywhere. And on this special classes on our app, I'm going to start advanced communication very soon. It's Bugs Bounty. If at all any of our educator, if at all our educator who is teaching here at the Unacademy is telling anything faulty, you can also report the same, for which you will get rewarded. Okay. This is where you can follow me on Unacademy app. Just you can download the Unacademy app and follow. This is the link to follow. And you can use the code GCR10 to get 10% off. In EMFT, we are continuing the questions of EMFT. Slowly we are trying to build up this concept and trying to explain some very important questions. We'll continue that. When question number 55, those who are joining me new, who had missed those questions, can go back to our previous marathons in which you can find all those questions. Yes, good afternoon everyone. Question number 55. Question number 55. The potential distribution function is given by V is equal to minus x square, then rho V, volume charge density rho V is dash coulomb per meter cube, is dash coulomb per meter cube. Apply Poisson's equation, you'll get the answer here. Apply Poisson's equation, you'll get the answer. Poisson's equation, del square V is equal to minus rho V by epsilon naught. Find the solution and tell me the answer here. Del square V, it is Cartesian coordinate system. Dou square V by dou x square plus dou square V by dou Y square, dou square V by dou Z square of V is equal to minus x square. This is 0. This is 0. You should do the derivative 2 times. Sorry. Yeah. Substituting del square we want, but V is minus x square. So this value will become 0. This value will become 0. So what do you get here? I'll write it here otherwise. Yeah, V is minus x square is there. V is minus x square is there. Dou square V by dou x square, 2 time derivative. 1 time derivative will give you minus 2x. 2 time derivative will give you minus 2. So del square V by del square V is minus 2 is minus rho V by epsilon naught. Implies rho V is 2 epsilon naught. Rho V is 2 epsilon naught. Option A is the answer. Very good. Yes. Next question. Cylindrical surfaces of radius, cylindrical surfaces of radius x, y, and z. X, y and z are such that x is less than, y is less than z, have areas of the cylindrical surfaces, have the areas of S1 area 20 meter square, S2 40 meter square, S3 60 meter square respectively, and they carry uniform surface charge densities of rho S1 is 2 coulomb per meter square, rho S2 is 4 coulomb per meter square, rho S3 is 6 coulomb per meter square. What is asking? Find the flux cut by the cylinder of radius R. How is R? It seems R is greater than Z, where of course Z is greater than Y, Y is greater than X. Find the flux cut by the cylinder of radius R. Where R is greater than Z, Z is greater than Y, Y is greater than X. The flux cut by the cylinder of radius R is dash coulomb. Length of each cylinder is 10 meter. Length of each cylinder is 10 meter. Solve it. Hint is you can apply Gauss law. Everyone share the session here. Like the session and share the session. It's a continuous marathons for you people. All day marathons. Almost we are taking all day marathons. This is the third consecutive day that we are taking all day marathons. Come on dear, everyone share the session. If you apply Gauss law, according to Gauss law, flux cut by any closed surface is equal to the charge enclosed by the surface. Psi E is equal to charge enclosed. But what is charge enclosed? Charge enclosed by cylinder 1 plus charge enclosed by cylinder 2 and charge enclosed by cylinder 3. How Q is related to rho S? Q is equal to surface integral of rho S ds. Q is surface integral of rho s ds. So what is Q1? Rho S1 into surface area. Rho S1 into S1 plus rho S2 into S2 plus rho S3 into S3. Rho S1 2 into 20, 4 into 40, 6 into 60. 40 plus 160 plus 360. 40 plus 160 plus 360. Total 560 coulomb. Question number 56, option D is the answer. Find this. Electric field E is equal to XAX plus YAY plus ZAZ. Is asking find the potential V at 1 comma 1 comma 1. You know V is potential V is minus integral of E dot dl. E is XAX plus YAY plus ZAZ. DL is DXAX plus DYAY plus DZAZ. E dot DL is x dx plus y dy plus z dz. Integral of E dot dl is integral of x square by 2, integral of y square by 2, integral of z square by 2. Minus integral of E dot dl is minus of x square by 2 plus y square by 2 plus z square by 2. Point is 1 comma 1 comma 1. 1 by 2 plus 1 by 2 plus 1 by 2. 1.5 minus 1.5. So V is minus 1.5 volt. Minus 1.5 volt. Question number 57. Option B is the answer. Very good, Arpit. Nandesh, Siri, very good. Keep going, very good. Next. Unit of vector magnetic potential is. The unit of vector magnetic potential is unit of vector magnetic potential is vector magnetic potential is given by symbol A. It is related to B, magnetic flux density as del cross A is equal to B. We know the relation between flux and flux density. Psi m is surface integral of B dot ds. Psi m is surface integral of B dot ds. But you know, B is del cross A. Therefore, psi m is surface integral of del cross A dot ds. Psi m is surface integral of del cross A dot ds. Apply Stokes theorem. If you apply Stokes theorem, this is closed integral of A dot dl. What is Stokes theorem? According to Stokes theorem, closed loop integral of A dot dl is surface integral of del cross A dot ds. For example, A is any energy source. Let me consider A is a light source. Then amount of light that is kept on this loop is equal to the amount of light that is oriented in this particular area. The orientation is given by del cross A, and this gives you surface area ds. Yes, got it. If you keep more number of lights on that wall or on that rope, more light will spread or orient in that particular area covered by the loop. Okay. That's a physical interpretation of Stokes theorem. Stokes theorem gives you relation between closed loop and open surface. What it tells you, the amount of light that is kept on the loop, amount of energy that is kept on the loop is equal to the amount of energy that is oriented in that particular area surrounded by the loop. If the length is known to us, then psi m is A into L. Implies A is psi m by L. A is psi m by L, which is Weber per meter. A is Weber per meter. Option B is the answer. 58B, very good. Next, if A is equal to 2AX plus 3AY plus 4AZ, then B mod of B is dash Tesla. The mod of B is dash Tesla. We know the relation between A and B. Del cross A is equal to B. Relation between A and B, del cross A is equal to B. If you do the curl of it, AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z, 2, 3, 4. If you evaluate this curl, all are constant value 0. The magnitude is 0. Question number 59. Option A is the answer. Yes. Question number 59. Option A is the answer. Next. Potential at point A is 10 volt. Potential at point B is 5 volt. Then VAB is given as VAB is given as VAB is VA minus VB. Answer is 5 volt. Question number 60, option C is the answer. Next. If H is equal to y square AX plus Z square AY plus X square AZ, then magnitude of del cross H is at what point? Minus 1 comma minus 1 comma minus 1. Del cross H is AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z, Y square, Z square, X square. Evaluate the debt. AX of 0 minus dou by dou Z of Z square 2Z minus AY of dou by dou X of X square 2X minus 0 plus AZ of dou by dou X of Z square 0 minus dou by dou Y of Y square 2Y. This is minus 2ZAX minus 2XAY minus 2YAZ. At minus 1 comma minus 1 comma minus 1, the value is two AX plus 2AY plus 2AZ. Mod of it. I want magnitude of it. Mod of it at minus 1 comma minus 1 comma minus 1 is under root of 4 plus 4 plus 4 under root 12. That's 2 root 3. Answer is 2 root 3. Answer is 2 root 3. Very good, very good. Which of the following does not represent Maxwell equation? Which of the following does not represent Maxwell equation? Which of these does not represent Maxwell equation? Maxwell equations for static fields. Equation number 1. Closed surface integral of d dot ds is volume integral of rho v dv. It's called integral form of Maxwell first equation. In differential form or point form, del dot d is equal to rho v. Source, Gauss law. Source is Gauss law. Second equation, closed loop integral of E dot dl is 0. Closed loop integral of E dot dl is 0. Differential form, del cross E is equal to 0. This from conservative property of electric field. This is from conservative property of electric field. Okay. Third equation. Is from Ampere's law. Closed integral of H dot dl is equal to I enclosed or surface integral of J dot ds. From this, del cross H is equal to J. This is from Ampere's law. Fourth equation, closed surface integral of B dot ds is 0. Differential form, del dot B is equal to 0. This is from non-existence of magnetic monopole, also called as Gauss law for magnetic fields. This Gauss law for electric fields. Are these equations matching there? Are these equations matching? No, I'm right. These are for static fields. If you write these for time varying fields, then equation 1 and 4 dot products will remain same. Cross products will vary. What is the change you'll have? Closed integral of E dot dl is surface integral of minus dou b by dou t dot ds. I'll write it again. This is for time varying fields, okay? Closed loop integral of E dot dl is surface integral of minus dou b by dou t dot ds. Integral form. Differential form, del cross E is minus dou b by dou t. Source, Faraday's law. Source is Faraday's law. Third equation. closed loop integral of H dot dl is surface integral of J, which is sigma E, JD, which is dou D by dou T dot ds. Differential form del cross H is equal to J plus JD. JD is dou D by dou T. Source Maxwell contribution. Also called as inconsistency of Ampere's law. Just I'm trying to revise Maxwell equations for you. This equation is from Faraday's law. This is Gauss law. This is Gauss law for magnetic fields or non-existence of magnetic monopole. This one is wrong because there should be dou D by dou T here. Therefore, option C is the answer. Anyways, answer is very simple. Just I want to revise Maxwell equations for you people. Modified Ampere's law is represented as modified Ampere's law. Ampere's law is del cross H is equal to J. J is sigma E, conduction current density. Modified form is you add a term called JD. Which is displacement current density plus dou D by dou T. If you write this in phasor form, dou by dou T is J omega. Substituting sigma E plus dou by dou T J omega epsilon E. This is modified form of Ampere's law. Modified form of Ampere's law. Del cross H is sigma E plus J omega epsilon E. Option A is the answer. Clear? Which of the following relation is not correct? Del cross E is minus dou B by dou T. Faraday's law. Del dot D is rho or rho V. Gauss law. Del dot B is zero. Non-existence of magnetic monopole. Which is not true. This one. What is this? Del cross H is equal to J plus JD. J plus dou D by dou T. Question number 64, option B is the answer. Yes. Tell me this. (45°). If a plane electromagnetic wave satisfies the equation dou square Ex by dou Z square is equal to C square into dou square Ex by dou T square. The wave propagates in dash direction. The wave propagates in dash direction. What is this equation? Let us see. What is this equation? Let us see. If you write Maxwell equations for time varying fields, del dot D is rho V, del cross E is minus dou B by dou T, del cross H is J plus JD, del dot B is 0. If you write this equation for free space, sigma is 0. Del dot D is rho V. Del cross E is minus dou B by dou T. B is mu naught H. Therefore, minus mu naught into dou H by dou T. Sigma is 0. Del cross H is epsilon naught into dou E by dou T. Del dot B is 0. Take this equation and do curl. Del cross of del cross E is minus mu naught dou by dou T of del cross H. This is A cross of B cross C, back minus cap rule. A cross of B cross C is B into A dot C minus C into A dot B. That is del cross of del cross E is del of del dot E minus E into del dot del square. For charge free region, rho V is 0. This will become 0. Del dot D is 0. Implies del dot E is 0. Therefore, this is 0. What is left out? Minus del square E. Substitute. Minus del square E is minus mu naught into dou by dou T of del cross H. Minus and minus cancel. Del square is mu naught into dou by dou T of del cross H, epsilon naught into dou E by dou T. Mu naught epsilon naught dou by dou T, dou square E by dou T square. Basing on the direction of propagation of the wave, we try to select del square E, because del square E is dou square E by dou X square plus dou square E by dou Y square plus dou square E by dou Z square. Basing on the direction of propagation, we need to select that particular direction, either X, Y or Z. If the wave is propagating along Z direction, then del square E is dou square E by dou Z square is equal to mu naught epsilon naught into dou square E by dou t square. This is called wave equation for the wave propagating in free space. Okay. Dou square E by dou z square is equal to mu naught epsilon naught into dou square E by dou t square. See here. Dou square E by dou z square is equal to mu naught epsilon naught into dou square E by dou t square. This is the wave equation for the wave propagating in free space. But you know, velocity of light c is 1 by under root of mu naught epsilon naught. Under root of mu naught epsilon naught is 1 by c. Mu naught epsilon naught is 1 by c square. Substituting, what do you get? Dou square E by dou z square is 1 by c square of dou square E by dou t square. This is wave equation for a wave propagating in free space. What is the velocity of this wave? How to calculate the velocity? You know, electromagnetic waves propagate with velocity of light. Am I right? So, how to understand if this is a wave equation? This must also represent the velocity of the wave. How to represent the velocity of the wave? If you take that equation, this is electric field by distance square is mu naught epsilon naught into electric field by time square. Cancel this off. Distance by time whole square is mu naught epsilon naught. We'll write it here. Distance by time whole square is 1 by mu naught epsilon naught. This is velocity square is 1 by mu naught epsilon naught. Velocity is 1 by under root of mu naught epsilon naught, which you know, which is c. That means what? It is representing a wave equation. It tells you that the electromagnetic wave is propagating with velocity of light. So this equation is a wave equation. Now what is given the question? You see carefully. Dou square E by dou z square is equal to 1 by c square of dou square E by dou t square is given. What is given the given question? Dou square Ex by dou z square is equal to c square into dou square Ex by dou t square. This is a wave equation for a wave propagating in free space with electric field component along x direction and the wave propagating along z direction. Answer is z direction. But what is the major difference here? I should get 1 by c square, I got c square. That means what? This wave will propagate in velocity. This wave will propagate in free space in z direction, but not with velocity of light, but with velocity of 1 by c. But of course, this represents wave equation only. This represents a electromagnetic wave only, but it propagates not with velocity of light, but it propagates with 1 by c here, because instead of 1 by c square, I got c square here. See this equation, I got c square here. This one. And what is that at solved? 1 by c square, dou square E by dou z square is 1 by c square of dou square E by dou t square. If it is 1 by c square, velocity of the electromagnetic wave is velocity of light. Instead of 1 by c square, it is c square. So the velocity is 1 by c. Clear? Next, intrinsic impedance of copper at high frequencies is, intrinsic impedance of copper at high frequencies is, tell me the answer here. Everyone share the session. Everyone share the session, like the session and subscribe the channel. At 4 o'clock, yeah. At 4 o'clock, Sathish sir will join the session. At 4 o'clock, there will be a layover for 2 minutes. We'll switch. And Sathish sir will join the session, okay? Intrinsic impedance of copper at high frequencies is intrinsic impedance of copper at high frequencies is intrinsic impedance of any medium with finite conductivity is eta is under root of j omega mu by sigma plus j omega epsilon. Copper is a good conductor for which sigma is far greater than omega epsilon. Therefore, second term can be neglected. The second term can be neglected. Eta under root of j omega mu by sigma. Eta is under root of j omega mu by sigma. Now we need to understand whether it is a pure resistance, pure inductive, pure resistive, pure inductive, complex with capacitive component, complex with an inductive component. What is the answer? What's the answer? $66. D. They are going for D. Eta under root of j omega mu by sigma. What is root j equivalent? Root j equivalent is one plus j by root 2. Root j equivalent is 1 plus j by root 2. How root j is 1 plus j by root 2? See here. Root j. Okay. Yes, Iqbal. Iqbal is going for C. Let us see. What will get the answer? Let us see. Now, how many of you know root j is 1 plus j by root 2? Tell me. How many of you know that root j is 1 plus j by root 2? Why root j is 1 plus j by root 2? Root j can be written as under root of 2j by 2. I'm right. Under root of 2j by 2. 2 and 2 get cancelled. Under root of 1 plus 2j minus 1 by 2, which is under root of 1 plus j whole square by 2. 1 plus j whole square is 1 plus j square minus 1 plus 2 into j into 1, 2j. Therefore, root j is 1 plus j by root 2 equivalent. Therefore, you can replace root j by 1 plus j by root 2. One plus j by root 2 omega mu by 2 sigma. This is in the form of x plus jy. Under root of omega mu by 2 sigma plus j times under root of omega mu by 2 sigma. X plus jy form. Positive reactance. Therefore, it is a complex quantity with the inductive reactance. Option D is the answer. Akshay, the questions, some of these questions may look the same for you because the content is not going to change drastically. Am I right? It does not mean that once I explain the concept on some other platform or some other day, it does not mean that these questions are not important. Okay. Some questions may be repetitive. Some questions will be repetitive, Akash. That does not mean that all the questions are repetitive. And one more thing, some part of the repeated thing does not mean that the question is not important. Once I explain on some platform, that does not guarantee at any point that is not important for anyone. Okay. Fine. The ratio of conduction current density to the displacement current density is given by the ratio of conduction current density to displacement current density is given by conduction current density JC, displacement current density JD. Conduction current density JC is given by sigma E. Displacement current density is given by dou D by dou T. If you expand this in phasor form, if you write dou by dou T is J omega D is epsilon E. E and E get cancelled. The ratio sigma by J omega epsilon is nothing but the ratio of conduction current density to displacement current density. Therefore, the ratio of conduction current density to displacement current density is nothing but sigma by J omega epsilon. Option B is the answer. Okay. Fine. Last one. The last question before we switch on, we switch over. Sathish sir will continue the marathon and I will join after Sathish sir. Last question before that. The velocity of a plane wave. Yesterday somebody asked me this question before I was concluding the session in the morning one. If at all the wave is in sine square form, what happens? If at all the wave is in sine square form also, you get omega and beta will not change. You get 2 omega, 2 beta, the ratio will be the same. Therefore, velocity will not change. Even though the wave is represented by sine square of omega t minus beta z, velocity v is omega by beta will remain the same. Sine square theta 1 minus cos 2 theta by 2 you get 2 times of theta. Omega will be multiplied by 2. Beta also will be multiplied by 2. The ratio will remain the same. So either the wave is represented by a sine function or the square function. The velocity is not going to change. If it is a square function, that does not mean that we get omega square by beta square. Okay. Velocity omega by beta. Yesterday someone asked me, I don't remember his name. But this is a concept there. You don't worry about this square term is represented or not. Whether it is square term or not, velocity function will remain the same. Yes, dear everyone. Everyone share the session, like the session, and I'll come back very soon. Sathish sir will continue the class, continue the marathon. So share the session and like the session. I'll come back very soon, dear.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with a test.
to bring out the best in you.
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you.
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with a test.
to bring out the best in you.
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you.
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to
Hello everyone, good afternoon to all. Hello everyone guys, good afternoon. Am I audible guys? Good afternoon to all. Am I audible guys? Saloni, good evening. Yeah, it's 4:10 hours already, right. Am I audible guys? Share the session. Share the session guys. Let's reach it to the maximum. Share the session. Let us discuss some more conceptual questions here. Arpit Singh, right. So Venkatesh, good afternoon. Share the session guys. So 11 members is the least numbers. Share the session guys. Let us discuss some more conceptual problems. So let me start the session, guys. So let me introduce myself. So I am Sathish Kumar. So I got AR 18 and AR 286. So now I had a 10 plus years of teaching experience. So I was expertise in the power electronics, so power systems and network theory. I did my MTech from power electronics. I was ex-BHL employee. So in Unacademy we have the plus subscription. So we have the plus subscription and iconic subscription. In plus subscription we have the live classes, crash courses, so weekly test, doubt solving. The classes will be held in both English and Hindi, right? So in iconic subscription we have the additional features like personal coach. So you will be allotted with the personal coach. So on study planner session study planners will be there. So study booster sessions will be conducted. So personalized test analysis is there. Preparatory study material and dedicated doubt clearing instructions are there. So this is the fee structure for plus subscription. So for 12 months, 18 months and 24 months. So if you use the code as KSK10, you will get the 10% discount. So after 10% discount, this is the amount here. So here you can opt for the no cost EMI also. So for iconic subscription, this is the amount for the 12 months, 18 months and 24 months subscription. So this is the amount after 10% discount if you use the code as KSK10. So the new initiative is ask a doubt. So you can ask doubts anytime. So ask unlimited doubts. So get assistance with the homework. So receive exact matches with the questions. So get the quality video solutions in both English and Hindi. So these the new batches are starting for electrical and ECE. So which was started on September 1st. The crack and Arohan for the electrical. So GATE exams, for it is related to the GATE. So the target is related for the ESE prelims. So these are the special class features. The special class are nothing but free classes which are available in the Unacademy Learner app. So these are all the free classes, interactive live classes. The polls for the learners will be created here. So the raise a hand option will be enabled here. So never miss a class. So you will get the notification once the class is scheduled. You can download the lecture notes here. So the classes can be watched at anywhere and anytime. So because it is an online platform. So Bugs Bounty, if you find any inappropriate content in the video, so you can report to the Unacademy. From there you can get the reward. So you can follow me in Sathish Gate, @Sathish Gate. So in Unacademy Learner app, so that whenever I schedule the special classes, so you can get the notification. So in this session, so let us continue with the power electronics remaining questions. So let me start with the first question. So before that, share the session, guys. Sandeep Deepu, good afternoon. Share the session, guys. 13 members is the least number for marathon. So share the session, guys. Let's start with the first question. Let me explain the question. Try to answer this question. So let me explain this question. So it was given as boost converter because by observing the circuit itself, I can tell that it is a boost converter. So in a boost converter, the inductor is placed at the source side. So that was clear. So and one more thing here, it is operating at the switching frequency 250 kHz. 250 kHz. Right? So the duty ratio is given as 0.4. So all the elements are ideal. The average value of the source current we need to find. So find the average value of the source current. So here Vs has given in the circuit itself. So observe the circuit. So Vs has given. So L value has given. So capacitance and resistance value also given. So what will be the source current here? Is there an easy method to find the source current? So the basics are required. The minimum basics are required to find the source current here. So that minimum basics would be, so for example, so let me explain the first question. So for example, if I take the source current here, right, source current will be here. The source current which is equal to average value of the inductor current. So here the source current is, the average value of the source current should be equal to, it will be equal to inductor current. So it will be equal to inductor current. How can we find the inductor current? How can we find the inductor current here? So we can find the inductor current if you observe in this circuit. So when the inductor current flows through the load, when will be the inductor current flows through the load? So what happens? There are two switches are there. There are two switches are there. So let it be the switch 1. So let it be the switch 1 and let it be the switch 2. So which switch has to be closed? So to get the inductor current, to flow the inductor current in the load. So which switch has to be closed? The second switch has to be closed. So if second switch has closed means, so the inductor current flows through the load. That is sufficient. If you know that, that is sufficient. So when will be the second switch will be closed? So the first switch will be closed during on time of the switch. So during on time of the switch, that is D into T, during dt period, the switch 1 will be in the closed condition. During the 1 minus d into t period, the switch 2 will be in the closed condition. So from that we can find the output current as, so output current is equal to, so IL into 1 minus d, IL into 1 minus d. So directly by observing the circuit without deriving anything we can write. So how we have wrote? So because during 1 minus dt period, so the inductor is flowing through the load. So remaining during dt period, so the inductor current is not flowing to the load. So from that, so I naught is so IL into 1 minus d, IL into 1 minus d, IL into 1 minus d. So if I got the I naught, so I can find V naught from here. So if I know the duty cycle, I can find the V naught. So I need to find the I naught here. How I can find the I naught? So now I naught equal to, we know that V naught divided by R, V naught divided by R. So now we got the, so if you got the V naught, so you can find the I naught easily, right? So now let us find the V naught. So V naught equal to V in into, so because it is a boost converter, so it will be the 1 by 1 minus d. 1 by 1 minus d. So V in into 1 by 1 minus d. So V in is given as 12 volts here, right? So 12 into 1 by 1 minus d. D is given as 0.4. So 1 minus d is 0.6. Right? So 12 by 0.6 is 20 volts. We got the V naught. So now let us find the I naught. V naught by R, 20 by 20. So which is equal to 1 ampere. So now we got the I naught as 1 ampere. So if I got the I naught as 1 ampere, so now let us find the IL. IL equal to I naught divided by 1 minus d. From this expression, IL equal to I naught divided by 1 minus d. So I naught is given as 1. And 1 minus d is the 1 minus 0.4. So 1 by 0.6, so which is nothing but 6 by 10, which is equal to 5 by 3. 5 by 3. So the answer is 5 by 3. So the answer is 5 by 3. Sudhir, it is for EEE students. So the power electronics is for EEE students. So for GATE and ESE. So the answer B is the right option. So the option B is the right option. So option B is the right option. Share the session, guys. Share the session. Let us discuss some conceptual questions here. So from there you can solve any question in the power electronics. Share the session, guys. Arpit Singh, B is the right answer. So it is 5 by 3. It is 5 by 3. So let us see the next question. So let us see the next question. So let me ask you one question here. So before going into the next question, so let me ask you one question. So before going into the next question, let me ask you one question. So what is that? So the line commutated inversion is possible in converters or not? Let me ask you one question. So the line commutated inversion is possible in rectifiers or not, converters or not? Line commutated inversion is possible in converters or not? So which is nothing but inversion. So when the converter can act as an inverter or not? Yes, yes. We will go through the DCM problems also. Sen Gupta. We will cover all the models which are in power electronics. We will cover. So let us see the next question. Let us see the next question. So the converter with the source inductance is 0. So the source inductance is 0. If I am assuming that this source inductance is 0, Ls is the source inductance, let it be the 0. If source inductance is 0, it is operating in the continuous conduction mode. So right, it is operating in the continuous conduction mode, and the load current is ripple free. So in load current there is no ripple, it is constant. So load current is constant, so that I naught equal to capital I naught. So which is a constant line. So which was represented as a constant line, right? So it is clear up to here. So what is the possible operations of the converter? So for this converter, so what are the possible operations? For this converter, what are the possible operations? So for this converter topology, so what is the possible operations? Right, let us answer this question, guys. Answer this question. So for all circuits, Sen Gupta, for all circuit it is not possible. So that some conditions should be satisfied. If alpha is greater than 90 degrees, so that is not the condition for line commutated inversion. So let us solve this question. So what was the option here? Arpit Gupta, B. Answer it, guys. Answer it, guys. So it is a good question. You can answer. If you can answer this one, you will get the concept in a clear manner. So answer this. Both. So how it is both? Let us see. So the both is the right answer, but how it is? Let us see. Manavalan S. So the rectification. So let us see answer. Let us see what is the answer. So from the explanation. So let us see what is the answer from explanation. Let me take this, right? Let me take this. Let me take this circuit. So let me explain. So the answer will be the both here. So why it is, let me explain here. Let me explain here. So if you observe the graph, so from that graph what we have to observe? So here there are two thyristors has given in the load. There are two thyristors are given in the circuit. So the first thyristor is T1, let it be the T1, and the second thyristor is, let it be the T2. Let it be the T2. So here we have two thyristors. The first thyristor is triggered at alpha, and the second thyristor is triggered at pi plus alpha. And the second thyristor is triggered at pi plus alpha. Now let us draw the output voltage. Let us draw the output voltage. Let us draw the output voltage. How the output voltage would be? So how the output voltage would be? Let us draw. So how the output voltage would be? So if I draw the output voltage, at alpha, what I am doing here? So I am giving the triggering pulse to the thyristor 1. If thyristor 1 is an on condition, what happens? If thyristor 1 is an on condition, what happens? This thyristor is in the on condition, right? If thyristor 1 is an on condition, what happens? The output is equal to, so the output equal to V naught equal to Vs. V naught equal to Vs. So here Vs we are taking as a sinusoidal waveform. Let me draw in a dotted line here. So Vs is in sinusoidal waveform here. Now, so here, so V naught equal to Vs during the period of 0 to pi. Unless if I trigger the device, what happens? So it continues. T1 still continues up to here. So T1 still continues up to here. So what happens if I trigger the T2? What happens if I trigger the T2? So if I trigger the T2 at that instant, so what happens? If I trigger the T2 at that instant, it will be closed, right? So the short circuit across the load, so the V naught will becomes to 0. V naught will becomes to 0. Now, when T2 is on at pi plus alpha, so be concentrated here, guys. So when T2 is on at pi plus alpha, so what happens? So it will be 0. So the output voltage is 0. Unless if I trigger the next device up to there, so it will be the output voltage is 0. So output voltage is 0. So here also output voltage is 0 because before this, if you assume that T2 is an on condition, the output will be 0. Now this voltage waveform we got the voltage waveform like this. So is it possible? Is it possible for line commutator inversion? So now you can answer, guys. So this is a rectifier circuit that is confirmed. Here inversion is operation is performing or not. So we should confirm that here inversion operation is performed. We can perform or not. Now answer, guys. Now answer it here by observing the output voltage waveform. So will you be able to tell that so the inversion operation is possible or not? Inversion operation is possible or not? So answer it, guys. Answer it. Inversion operation is possible or not? Rishabh Dev? No, sir. Okay, let us see more. So right, if I increase the firing angle, what happens? If I increase the firing angle alpha to the, so greater than 90 degrees, what happens? Let it be the 90 degrees point. What happens? So it will shift to the pi plus alpha, shift to the pi plus 90, right? So pi plus 90. If I keep the 90 degrees, if alpha is greater than 90 degrees, what will be the output? The output will be like this. This output will be like this. The output waveform would be like this. Let me draw with other color. The output waveform would be like this. When alpha is greater than 90 degrees, what happens? So the output waveform is like this. If I find the average voltage, so how it will be? If I find the average voltage for this waveform, so for this waveform, how the output voltage? So what is the polarity of output voltage? Here the positive value is less when compared to the negative value. So the negative area is more when compared to the positive area. So that if I find the output voltage when alpha is greater than 90 degrees, here also the output voltage is negative. So here also the output voltage is negative. So but the current is always positive, so which is constant. We are assuming that the current is positive, which is constant. So which is constant. The current is positive. I0 is positive. If I find the power, so after 90 degrees, what happens? If I find the power after 90 degrees, V0 into I0 is the power, right? V0 into I0. If I find the power, so the positive into negative, the power is negative. What does it mean? The power is negative means what does it mean? So the power is delivering from the load to the source. If the power is delivering from the load to the source, at alpha is greater than 90 degrees, so it is converting from DC to the DC load to the, so AC. So what we can call it as a, so which is the inversion operation. So are you clear? If you have any doubt, you can ask, guys. Yes, Sen Gupta, it is possible. Saloni, right? Yes, it is possible. Rishabh Dev, so do you understand this concept or not? Now confirm me. So this concept is, if you understand this concept or not. So right, V0 is negative. So V0 is negative when alpha is greater than 90 degrees. In this case also. So the line commutation inversion is only not possible. It is not only possible in the fully converter. So it is also possible in different topologies of the converter circuits. This is the one of the topology. So this is the one of the topology. Now what is the answer here? So the answer would be, so what is the answer here? So the answer is, so it is possible with both rectification and inversion process. If you have any doubt, you can raise, guys. Rishabh, no need to say sorry. So it is always learning. So both the sides we need to learn. Right. So if you understand this concept, let us move forward. So let us see the next question. So let us see the next question, guys. If you understand the concept, so let us see the next question. So what is the question here? So let us see the next question. What is the question here? So it is a three-phase fully controlled bridge converter. So feeding and load is drawing in the constant ripple free current. So this current is given as 10 amperes. Let the I naught is 10 amperes. So I naught is given as 10 amperes. 10 amperes, and the firing angle is given as 30 degrees. Firing angle is given as 30 degrees. So the approximate THD. So we need to find the percentage of THD, that is total harmonic distortion, right? So one more thing we need to find, RMS value of the fundamental input current. So fundamental input current RMS value we need to find. So IS1 RMS value, so we need to find here. So IS1 RMS. So for the full converter we need to find this. So let me give the formulas for the three-phase full converter and semi-converter here itself, so that if the problem data even changed, so you are able to answer the question. So let us do that. Let me give the basic concepts and basic formulas to solve this question, so that you are able to solve by yourself itself. So now if I take the three-phase full converter and three-phase semi-converter here itself, let me take the three-phase semi-converter. So now if we find the V naught, how the V naught will be? So V naught equal to 3 into VML. So the maximum line voltage divided by pi into cos alpha. So if I find the V naught for the three-phase semi-converter for this case, so it will be 3 into VML by pi into 1 plus cos alpha. 1 plus cos alpha. So now we got the V naught, right? So now let us see the IS1. So what is IS1? Fundamental RMS source current. So the fundamental RMS source current would be here root of 6 by pi into I naught. So which is equal to 0.78 into I naught. 0.78 into I naught. So here IS1 in the three-phase semi-converter will be 0.78 into I naught into cos alpha by 2. So if I want to find the displacement power factor, or fundamental power factor would be, so it will be the cos alpha. So here it is cos alpha by 2. So for example, if I want to find the distortion factor, so now distortion factor, let us find the IS. So RMS value of the source current would be, so for the three-phase full converter, RMS value of the source current will be, so I naught into root of 2 by 3. So in case of semi-converter, so it will differ for the alpha value. When alpha is less than 60 degrees, so it will be the I naught into root of 2 by 3. When alpha is greater than 60 degrees, it will be the I naught into square root of pi minus alpha by pi. Pi minus alpha divided by pi. So now, so we got the IS value, so that is source current. So displacement power factor IS1 and V naught. So let us see the remaining parameters. Distortion factor G equal to IS1 divided by IS. So we know the IS1 and IS, from that we can find distortion factor. Input power factor equal to distortion factor into displacement power factor. So that is G into displacement power factor. How we can find the THD here? So THD equal to square root of 1 by G square minus 1 into 100. 1 by G square minus 1 into 100. So how the G can be evaluated? IS1 by IS. So if any data is changed, whether they have given the three-phase semi-converter, so or they have given the three-phase full converter, so if you use these formulas, you can solve these type of problems very easily. So these formulas are sufficient to find these type of problems, for the solution for these type of problems. Now let us solve the question. I think everyone has answered. Now let us solve the question. Let me solve the question here. So I naught has given, IS1 has given. So we need to find the IS1, right? So how we can find the IS1? So from the formulas, IS1 for the full converter will be the 0.78 into I naught. 0.78 into I naught. So what will be the 0.78 into I naught? 0.78 into I naught would be 10 amperes. So which is equal to 7.8 amperes. 7.8 amperes. So if I got the IS1, so I can find the distortion factor, G value. So G value, G equal to IS1 divided by IS. G equal to IS1 divided by S. So for that I need to find the RMS value of the source current. How I can find the RMS value? So RMS value of the source current equal to I0 into root of 2 by 3. So 10 into root of 2 by 3. 10 into root of 2 by 3. So I need to find the 10 into root of 2 by 3. So which is 8.165. 8.165. 8.165 amperes. Now I got the IS value and IS1 value both. So IS and IS1. Let me find the G value. Let me find the G value. Let me find the G value. So G equal to IS is given as, so IS1 is a 7.8, distortion factor equal to 7.8 divided by 8.165. So I will get the G value as 7.8, so 0.955. 0.955. Now from this I need to find the THD. So the percentage of THD equal to square root of 1 by G square minus 1. 1 by G square minus 1. So which is equal to square root of 1 by 0.955 square minus 1. Minus 1. So I think it will be the 31.1%. 31.1%. So now let us see the options. So 31% and the 7.8 amperes. Option B is the correct option. Let us see how many of you answered correctly. So option B is the correct option. So Vivek Yadav, you are right. Option B is the correct option. Be interactive, guys. Be interactive. So let us discuss more conceptual questions here. So be interactive. So the option B is the correct option. If everyone is clear, let us move to the next question. If everyone is clear, let us move to the next question. Right, respond guys. Be interactive, respond guys. Let us discuss more concepts here. Let us discuss some new questions as well as more concepts here. Be interactive. So let us solve the next question. Let us solve the next question. Let us solve the next question. So what is the answer for this? So let me explain the question first. A diode in anti-parallel. So a diode in anti-parallel with the control switch like IGBT is used in VSI. So VSI is nothing but voltage source inverter. So why we are using the diode? So why we are using the diode in anti-parallel with the controllable switch like IGBT in case of voltage source inverter? VSI is nothing but voltage source inverter. Voltage source inverter. So why we are using the diode? So why we are using the diode? So across IGBT. Across IGBT. Share the session guys. Share the session guys. Let us discuss few more questions. Let us discuss few more conceptual questions. Share the session. So what is the answer for this? So what is the answer for this guys? So here why we are using the diode across the IGBT? So anti-parallel with IGBT. Generally we will use the diode with anti-parallel with an IGBT. So anti-parallel with an IGBT. So in case of voltage source inverter. So what is the function of this diode in voltage source inverter? What is the function of diode in case of voltage source inverter? Load current reversal. Load current reversal. Is there any option like that? Right, B. So it allow the, so option B is the right option. Option B is the right option. Let us see why it is. Let us see why it is. So we should know the reason also, right? So we should know the reason also. For example, if I take the voltage source inverter if I take the voltage source inverter, so if I take the voltage source inverter, if I take the voltage source inverter, so with the load here, so what happens? With the load here, what happens? Let this switch will be the 1 and let this switch will be the 2 and 3 and 4. 3 and 4. If I close the 1 and 2, if I close the 1 and 2 switches, let VL, so V0 will be like this, let V0 will be like this, and I0 is also like this. So I0 will be, reference will be positive here. If I close the 1 and 2, what happens? If I close the 1 and 2, the output voltage would be like this. So if I output voltage would be positive, which is equal to Vs. So if I close this 1 and 2 switches, so what happens? This plus of Vs is connected here and minus of Vs is connected here. So it will be the plus Vs, right? So now if I close the 3 and 4 in the remaining section, so T by 2, let it be the T by 2. So it will be the T. So what happens? If I close the 3 and 4, what happens? So the V0 will be the negative. So V0 will be the negative. So V0 is negative. So for resistive load, there is no problem. For resistive load, there is no problem. Why? Because, see, for the resistive load, how the current would be? So the current would also be same. The current also will be same. So the current will be like this. So for resistive load, the current is the V0 divided by R. So the current will be same. The current will be same. But, so if I use the inductive load, which is the non-unity power factor load. If I use the inductive load, what is the? So if I use the inductive load, the current waveform will be like this. So the current waveform would be like this. So it would be like this. Let me represent with other color. So the current waveform would be like this. So what happens during this time? So to maintain the voltage source inverter is nothing but, so it will maintain the constant voltage independent of the load parameters. Even if I change the load parameters, the output voltage should not change. So for example, in this case, in this period, what is happening in this period? So to maintain the Vs here, so the current should be reversed. So the current should be negative when the output voltage is positive. So for that, I need to take the diodes here. If I keep the diode, during that time, what happens? So when these two diodes is in on condition, the output voltage is positive, but the current is flowing in the reverse direction. How the current flows? The current flows in this reverse direction. So assumed direction, it is reverse to the assumed direction. So to allow the current in the reverse direction in case of non-unity power factor loads, so we need to add the diodes. Similarly here also, so here the current is negative. For this we need to add the diodes. So now these diodes will be added here. So the complete circuit, so for resistive load there is no requirement of the diodes. There is no requirements of the anti-parallel diode. But in case of non-unity power factor loads, to reversal the current, so we must use the diodes. So this is the function of diode. So option B is the correct option, guys. Option B is the correct option. Raj Gaurav, you are right. You are absolutely right. So let us see the next question, guys. So let us see the next question. So let us solve this question, guys. So what is this question? Let me explain the question first. So SCR with a specified TQ of, TQ is nothing but turn of time. So here the TQ is nothing but turn of time. So TQ is turn of time. So the turn of delay is given as 0. There is no turn of delay. Right? So which is 0 seconds. So used in the converter. So now, what is the maximum value of VD? So VD is nothing but output voltage. So what is the maximum value of, let it be the VD or V0. So VD or V0. So which is the output voltage of this converter. So what is the maximum of VD? So which converter can invert? So when this converter will act as an inverter, so for example, if I'm using the LS equal to 0, that is source inductance is 0, what happens? If source inductance is 0, what happens? If source inductance is 0, when alpha is greater than 90 degrees, this converter can act as an inverter. This converter can act as inverter. That we know that. So this converter can act as an inverter when alpha is greater than 90 degrees. This converter can act as inverter. But when LS is considered, so I need to find so when it is operating in the inverter, so what is the maximum voltage it can get? So when it is operating in inverter, the question is simple. When it is operating as an inverter, so what is the maximum voltage of the converter? What is the maximum voltage of converter? So this is the question, guys. Maximum voltage of converter. This is the question. So if you understand this question, so let us solve this question. So this question difficulty level comes under medium level. So let us solve this question. So what is the VD value? Arpit Singh, so is that polarity is minus or plus? So is that polarity is minus or plus? So is that polarity is minus or plus? Because it should act as an inverter. So it should act as an inverter in that sense. So the output voltage should be negative. The output voltage should be negative. So let me explain this question, guys. Let me explain this question from the basic concepts. Let me explain this question. So let me take this diagram. So let me explain this question. So let me explain the concept first. After that, you can easily solve the question. You can easily solve the question. So let me explain the question first. So let me explain the question. Now, so here the 4 thyristors are there. So let me explain the effect of source inductance. So let me give the basics of effect of source inductance. So from that, let us solve the question. So let it be the thyristor 1. So this thyristor would be the thyristor 2, and this is the thyristor 3, and this is thyristor 4, right? Let me name it as a 4 thyristors. So for example, if I write the, so let me represent the Vs. So let me draw the Vs. So Vs equal to Vm sin omega t. So if it is A terminal, let me think A and B terminals here. So VAB equal to Vm sin omega t. So now let me draw the VAB first. VAB equal to Vm sin omega t, right? So let it be the VAB. Let it be the VBA is the minus Vm sin omega t. So the source voltage, if I name it as A and B here, so VAB equal to Vm sin omega t. If I want to draw the VBA, it should be exactly opposite phase to the 180 degrees. So now let me draw the VBA. So if I tell the concept, you can understand easily. How we can find the output voltage. Let us see. So it is a VBA. Now we got the VAB and VBA waveforms. So from this, if I give the triggering pulses, so if I give the triggering pulse for the 1 and 2 at alpha, let it be the alpha. So I have given the triggering pulse for the 1 and 2 at alpha. So I will give the triggering pulse for the 3 and 4 at pi plus alpha. Again at 2 pi plus alpha, I will give the triggering pulse for the 1 and 2. So what happens if I give the triggering pulse for the 1 and 2? So if I give the triggering pulse for the 1 and 2, so 1 and 2 switches will be in the on condition. So this 1 and 2 switches are in the on condition. So when 1 and 2 switches are in the on condition, so what is the output voltage? So let it be the A terminal and B terminal. So output voltage is equal to VAB. Output voltage is equal to VAB. But so now let me draw the current first. Let me draw the current first. Let me draw the load current. Let me draw the thyristors current. So how it will be, let us see. So we are assuming that load current is constant here. Load current is ripple free and it is constant. So when alpha is, because of source inductance, what happens? Because of source inductance, the current will not reach to the I0 immediately. So the inductance property is, it doesn't allow the sudden change in the current. So that what happens? The current will increase slowly. The current will increase slowly, and then it will go to the, so T1 and T2 will be it will go to the I0. So here T1 and T2 are in the on condition. T1, T2. Let it be the T1, T2. The current due to the T1, T2 is positive. The current due to the T1, T2 is positive, right? Let the load is here. So the current to the, so T1, T2 is positive here. Now at pi plus alpha, what we are doing here? At pi plus alpha, we are triggering the T3 and T4. So if I trigger the T3 and T4, what happens? These T1 and T2 has to be turned off. So how it will be turned off? So if it does not having the source inductance, immediately the current will be zero. But it takes some time. It takes some time. So it takes some time, right? So the current will be like this. So again the current will be start from here. Again the current will be start from here. Because again I am triggering at T1 and T2. Now, if I draw the current for T3 and T4, if I draw the current for T3 and T4, how it would be? So if I draw the current for T3 and T4, so the current would be like this. So if I draw the T3 and T4, if I close the T3 and T4, what happens? T3 and T4, what happens? So what happens? So the B terminal is connected to this B terminal is connected to the positive of the V0, and this A terminal is connected to the negative of the V0. So the output voltage is VBA. Output voltage is VBA. So is that current will be, load current will be in the same direction. So load current will be same direction in the rectifier, but the source current will be the negative. Source current will be the negative. So now, so here, so the current will start from pi plus alpha. Let me draw with other color. The current will start from pi plus alpha, T3, T4. So again it will reach to the, I0. Because of source inductance, it is taking some time. Because of source inductance, so it is taking some time. So again it will be like this. So again it will be like this. Because, so before T1, T2 here, so if I am taking as the load current constant, T3, T4 has to be on here. T3, T4 has to be on here. Now if you observe here, so this period will be the mu, right? So this period we will call it as a mu because, so during that condition, mu is a overlap angle here. So mu is nothing but, so this will be the overlap angle. This will be the overlap angle. So this will be the overlap angle. Now, so up to here we are clear. So during overlapping period, what happens? The T3, T4 is still in on condition, right? The T3, T4 is still in on condition as well as T1, T2 is also on condition. During this overlap period, T1, T2, T3, T4, 4 devices are in on condition. If 4 devices are in on condition, what happens? The output voltage will become 0. The output voltage will become 0. So if I draw the output voltage, how it would be? If I draw the output voltage due to up to here, so during overlapping period, our output voltage is 0. So when T1, T2 is in on condition, it will be the VAB, right? It will be the VAB. So again, during overlapping period here, so during overlapping period here, up to here, from here to here, so what happens? The output voltage is 0. So when T3, T4 is in on condition, here the T3, T4 are in on condition. If T3, T4 are on condition, what happens? The output voltage is VBA. So the output voltage is VBA, right? So again it will be like this. So it will be like this, right? So it will be like this. So the output voltage will be like this. So this is how we'll get the output voltage and so currents here. So why I have explained all these things, if you know the concept, you can connect with this problem. If you know the basic concept, you can connect with this problem. So now we need to find the maximum value of voltage. VD maximum, so that is output maximum voltage we need to find. For that, so we need to find the maximum value of alpha. So on the maximum value of alpha, so on which parameter it will depend? So it will depend from, so if you observe here, even if I give the alpha here, so let me represent with other color. Even if I give the firing pulse here, so what happens? So it is started at pi plus mu. It is started at alpha plus mu. alpha plus mu. So if I want to find the alpha max, so it should be the 180 minus mu max. So the maximum value of alpha is depends on overlap angle. So if I can find the alpha max, the first point is, so here we need to find the maximum value of firing angle. For that, it is depends on overlap angle. If I subtract the overlap angle from 180 degrees, I can get so what is the value of the maximum alpha? So what is the value of maximum alpha? So because alpha to pi plus alpha 180 degrees are there, but the conduction starts at pi plus mu. So to get the maximum value of alpha, it depends on mu max. It depends on overlap angle. How can we find the mu max? Let us see. So let me write the equations here. First I will write so by using the effect of source inductance, we will derive this expression. Here I am not deriving because it's not here. So it is here we are going to solve the problems. So I will take the concepts from that. So now cos alpha plus mu equal to, so from this we will derive the expression. So cos alpha minus 2 omega ls divided by Vm into I naught. 2 omega by ls into Vm divided by I naught. So this is the cos alpha plus mu. So here to get the alpha max, so what is the condition here? So alpha max, how we can find? So 180 minus, that is pi minus mu max. Substitute for getting the mu max in this equation as an alpha max. So let us derive the expressions first. So after that, so if you substitute the answer, you will get the answer. So cos alpha, if I substitute in place of cos alpha, so if I substitute the pi minus mu max plus mu max, let it be the mu max. So we are deriving for the maximum voltage. That's why I am keeping as alpha max and mu max here. So next, cos pi minus mu max. So in place of alpha, I am substituting the pi minus mu max minus 2 into omega ls divided by I naught. So from this, so mu max and mu max will get cancelled out. Cos pi is the minus 1. So if I substitute this one, so cos pi is the minus 1. We can substitute in this. Cos pi is minus 1. So minus 1. So cos pi minus mu max is minus cos mu max. Right? Minus cos mu max. So now if you substitute it is a minus 2 omega ls divided by I naught. So omega ls into I naught divided by Vm. Right? So now we got the expression here. So from this we can find the mu max. So cos mu max equal to, if I take this side, cos mu max equal to, so what is the expression? So 1 minus 2 omega ls I naught divided by Vm. So cos mu max, from this cos mu max expression, I can find the mu max. So after finding the mu max, what we have to do? After finding the mu max, I can find the alpha max. By pi minus alpha max. So pi minus alpha max equal to pi minus mu max. Right? From that expression, we can find the mu max, that is overlap angle, maximum overlap angle. So from this expression, we can find the alpha max. So from this expression, we can find the V naught value, V naught max. So V naught will be Vm by pi into cos alpha plus mu, cos alpha mu, cos alpha max plus mu max. So cos alpha max plus mu max. So this is the theory behind this problem. So if you know the basic theory, you can connect. So but to understand this problem, so you must know that, so how the effect of source inductance on converter. So if you know this, so you can find easily. So now from this expression find the mu max. So after that, find the alpha max. So after that, substitute in the V naught max. After that, substitute in the V naught max. So now let us do the problem here. Now let us do the problem here. So now let us do the problem here. Let us do the problem. So let us do the problem. So what is the thing here? What is the thing here? So we need to find the mu max. How we can find the mu max first? So in this expression we need to substitute. So cos alpha plus mu equal to, so this expression we will get in the effect of source inductance 2 omega ls divided by Vm into I naught, right? So in this expression now what I have to do, I need to substitute the alpha max, which is the pi minus mu x. If I substitute in this, I will get the 1 here, right? Minus 1 here, right? Minus 1. So cos alpha minus mu x is the minus cos mu x minus cos mu max minus 2 omega ls by Vm into I naught. So omega is given as 314t. So in this problem, omega is given as 314t. So 2 into 314 omega. So ls is given as 1 millihenry. Ls is given as 1 millihenry, 1 into 10 power minus 3. So divided by Vm is given as 230, and I naught is given as, in this problem I naught is given as 40 amperes. I naught is given as 40 amperes. So this one, I naught is given as 40 amperes. Now let us find this. So I naught is 40 amperes. So into 40 amperes. So let us find the mu max from this. So if you find the mu max, so after that we need to find the alpha max. Guys, are you following? Up to here you are clear or not? Up to here you are clear or not? Arpit Singh, if the source inductance is negligible, so we should take the mu is 0. So mu is 0. But here that is not mu. TQ is nothing but turn off delay time of the, so TQ is nothing but turn off delay time. Turn off delay time is nothing but, if you know that so in a MOSFET or IGBT there is a turn off transition, right? That time he has given. So which is given in generally, which is given in data sheet. So here if TQ is given, so we need to add the TQ also in the mu. So because of, but mu is depends on inductance. Here the mu is depends on, this overlap is depends on inductance. So the TQ is depends on device turn off time. TQ is the device turn off time. So now let us find the mu max. What is the mu max here? Let us find, guys, what is the mu max here? So what is the mu max value? So 2 into 314 So 27.02, guys, 27.02. Mu max you will get the 27.02. 27.02. So this problem comes under difficult level, medium difficult level. So it is not that easy. So you should know the basic concepts. From that only we can derive this problem. So if you know the mu max, so let it be the 27 degrees, 27.02 degrees. So now let us find the alpha max. So what is alpha max? Alpha max equal to 180 minus mu max. So which is equal to 180 minus 27. 180 minus 27.02. So 152.98. So if you know the mu max and alpha max, you can find the output voltage. We can find the output voltage. If I integrate the output voltage waveform, I will get the output voltage expression as Vm by pi into cos alpha plus cos alpha plus mu. Cos alpha plus mu. Here we need to substitute the maximum values. Here we need to substitute the maximum values. So Vm is the 230, right? So 230 divided by pi. So 230 divided by pi. Cos alpha we got as the cos alpha max is the cos 152.98. 152.98 cos alpha plus mu. If alpha max equal to 180 minus mu max, so alpha max plus mu max equal to 180. So it is 180 plus cos 180. Now let us find the output voltage. 230 divided by pi into cos 152.98 plus cos 180 minus 138.43. Minus 138.43. So how we know that? So the answer is correct or not? So if the output voltage is negative, we can tell that. So if the current is positive and output voltage is negative, so if you find the power, what happens? The power is negative. If the power is negative, is nothing but it is acting as an inverter. So the answer will be the minus 138.43. If you know the concept, it is easy, guys. But connecting the concept to the problem is difficult. It is difficult. It is not a difficult problem. It is an easy problem. But we should connect the concept to the problem here. Guys, if you have any doubt on this, you can ask. Because this problem takes some time. So to understand this problem is you need to have some basics. If you are missed with any basics, you can ask here. Maybe till now you haven't faced this type of problem. So I think this is the fresh problem for you. Yes, Raj Gaurav, 27.02 is the mu max, right? You are right. Arpit Singh, what is the problem here? So what you are not understand here? Any basics you are not related to this problem? So is it you are facing difficulty? So where you are facing the difficulty to understand this problem? So mention one place, I will explain. Right. Let me explain you, Arpit Singh, once. So all of you, let me explain this concept once, so that if you have even any doubt here, so you will understand clearly. So because here you need to the source, you need to understand the problem first. Let me come from the problem. If anyone is not following this, let me explain this one, because this problem has that difficult level. If you are not having the basics, you cannot connect to this problem. So now let me explain once. What is the problem here? So here the TQ is given as 0. What does it mean? TQ is nothing but turn off time of the device. So we are not considering the turn off time of the device. So what does it mean, turn off time of the device? So we are not so this delay is due to the inductance in the circuit. But not due to the turn off time of the device. So this turn off time is given as 0. So this is the TQ is nothing but turn off time of the device. This mu is due to this overlapping is due to this mu is due to the source inductance nature. This mu is due to the source inductance. This overlap is due to the source inductance. Let us understand in a clear manner. This overlap is due to the source inductance. First we should be clear with this. So overlap is due to this overlap delay is due to the source inductance, and this in the problem TQ has mentioned TQ is nothing but turn off time of the device. So up to here we are clear, right? So now let us go forward. If TQ has given, what happens? The delay will more. If TQ has given, how I can find the alpha max? In a problem, it was given as TQ as 0. For example, if in a problem TQ has mentioned, that is turn off time of a device has mentioned, so how we can find? So which is the 180 minus, so the delay due to the overlap angle, plus the delay due to the overlap angle plus omega into TD, omega into TQ. So the alpha max equation will vary. If TQ is mentioned in the problem, so we should consider the TQ. But here, so we should make the TQ as 0 here. So from this we have found. So the difference between the TQ and mu you need to understand here. TQ is the device delay, mu is the overlap delay. Yes, we need to know the one parameter, right? Either alpha or mu we need to know to go forward. So for that we have taken the initial condition alpha max. So after that, from that we have found the mu max. So let us move to the next problem, guys. In detail course we will discuss this problem very clearly. So when I was discussing the source inductance, attend that class. So I will discuss each and every point here very clearly. So let us go to the next problem. Here let us solve the more problem series. So see, what is the answer here? So what is the answer here? So it is a simple problem. So it comes under low levels. So not the medium level also. Difficulty level is very low. So here let us find the solution for this. So what is the problem here? First observe that what is the problem. So here, so let me explain what is the problem here. So it is voltage source inverter. This circuit is voltage source inverter circuit. So this circuit is voltage source inverter circuit. So it is provided with the 50 H, right? Square wave AC output voltage across the RL load. So the load is RL load, clear. So now, so the output voltage reference direction. So R is the 3 ohms. R is given as 3 ohms. So L is given as 9.55 millihenry. So what we have to find? When V0 is less than 0, that means V0 is negative, I0 is greater than 0, so the pair of the devices which conducts for the load current. So which devices will conduct during this condition? The question is, when V0 is negative, I0 is greater than 0, which devices will conduct? So in option A it was given as Q1, Q2, Q3, Q4 and D1, D2 and D3, D4. So answer this question, guys. So this is easy question. Answer this question. So this is easy question. Answer this question. Answer this question, everyone. Be interactive, guys. Arpit Singh, D. So D is the right option. We will see why it is D. So D is the right option, guys. We will see why it is D. Let us see why it is D. For example, it is a voltage source inverter, right? So the output voltage will be like this. The output voltage of the full bridge inverter will be like this, right? It will be the Vs and it will be the minus Vs. If I draw the current for the RL load, so this waveform lags, the current lags the voltage by some angle, so which will be the pi. Let it be the pi. So the current waveform would be like this. So when voltage should be negative, voltage should be positive, so current is negative. So when voltage is, the first condition here is, so from here to here, so if you observe here, the voltage is positive. So the voltage is positive and current is negative here. And voltage is positive here. during that period. So during that period, which devices will conduct? So voltage should be positive is nothing but, so V0 should be greater than 0. V0 should be greater than 0. When V0 is greater than 0, so if you observe here, so either Q1, Q2 or D1, D2. So if these devices in on condition, the output voltage is positive. Why we will see here. So for example, if Q1, Q2 is an on condition, if Q1, Q2 is an on condition, so it will be like this. If Q2 is an on condition, it will be like this, right? So what happens? So what happens here? So if Q1, Q2 is an on condition, Q1 is an on condition, so the positive terminal is connected to the plus of the V0, here the plus of the V0, and the negative terminal is connected to the minus of the V0, so that Vs equal to V0, Even if D1, D2 is on condition, so Vs equal to V0. So V0 equal to greater than 0 condition will be satisfied by the Q1, Q2 and D1, D2. Q1, Q2 and D1, D2. But when Q1, Q2 is an on condition, the current direction would be like this. When Q1, Q2 is an on condition, the current direction will be like this. So that means assumed direction and current flowing direction both are same. So I0 is greater than 0. So for the D1, D2, what happens for the D1, D2? So if the D1, D2 is an on condition, what happens? So the current direction would be like this. This diode will conduct in this direction, right? So the current direction would be like this. So which is the opposite direction of this one. So the current direction is opposite direction to the assumed direction. So when D1, D2 is in on condition, I0 is less than 0. I0 is negative. Similarly, for V0 is less than 0, V0 is less than 0. So what happens? V0 is less than 0 means, so which of the device will conduct? So when V0 is less than 0, Q3 and Q4 will be in the on condition. Q3 and Q4 is in the on condition. If Q3 and Q4 is an on condition, what happens? V0 is negative. So V0 is negative. Similarly, if D3 and D4 is an on condition, V0 is negative. So there are two possibilities for this. So here Q3, Q4 and D3, D4 will be on condition. But when Q3, Q4 is an on condition, so I0 is negative. So that is I0 is less than 0. If D3, D4 is an on condition, I0 is greater than 0. So here we need to find that V0 is less than 0 and I0 is greater than 0. So for this condition, D3 and D4 devices should be in the on condition. So where this condition came? So here. So at this place, so V0 is negative and the current is positive. So during this period, D3 and D4 are in the conduction state. So the answer will be D3 and D4. The answer is D3 and D4. So the answer is D3 and D4. Guys, it is clear, right? So V0 is greater than 0. We should find that. So which of the devices are the possibilities? So from that possibilities, let us find the answer. So that answer will be the D3 and D4. So D3 and D4. So option D is the correct option. D3 and D4. So let us see the next question. So this is the question, guys. So which option is correct? Let us see some simple questions too. So which option is correct? So this is a simple question. So by simply observing, you can write the answer. So which is the simple question, guys? What is this question? So three-phase inverter has given. So here the three-phase inverter has given. Bridge inverter. So which is operating at 180 degrees mode of conduction, right? 180 degrees mode of conduction. So the sequence of SCR conduction in the first two steps. The sequence of SCR conduction we need to mention. So beginning with initiation of the thyristor 1 is. So here the thyristors are named as 1, 3, 5. So 2, 4, 6. So for this case, so what are the beginning of the two states? For 180 degrees mode of conduction. Can anyone answer this? So easy question, guys. Which is a easy question? So which is a easy question? Answer this question, guys. Answer this question. So what is the starting sequence? What is the first two sequences? So let me explain once. If the question is altered, if the question has altered data, so anything, so you must be able to answer the question. So let us see. So basic shortcut here. Let us see the basic shortcut here. So here, if you observe here, so in a three-phase inverter, we have the two types of conductions. They are 180 degrees mode of conduction. They are 180 degrees mode of conduction and 120 degrees mode of conduction. 180 degrees mode of conduction and 120 degrees mode of conduction. So in 180 degrees mode of conduction, at a time, 3 devices will conduct. So at a time, 3 devices will conduct. So for the same instant, so at any case, at any instant, if you take 3 devices will conduct. So in 120 degrees conduction mode, 2 devices only conduct. 2 devices only conduct. So here, so it will be the, so 5, 6, 1. So the starting sequence will be the 5, 6, 1. And here the starting sequence will be the 6, 1. 6, 1. So if it is 5, 6, 1, so what is the next sequence? The next sequence will start from 6. So we have the 6 devices, 1, 2, 3, 4, 5, 6, right? So we have the 6 devices, right? So if the starting sequence is 5, 6, 1, so the next sequence will be the 6, 1, 2. Next sequence will be the 6, 1, 2. So what is the next sequence? 6, 1, 2. After that it will be the 1, 2, 3. So what is the next sequence? 2, 3, 4. So like that it has the different sequences. For the 6 sequences it have. So for example here also it is starting from 6, 1. So what is the next sequence? 1, 2. So what is the next sequence? So 2, 3. So like that it has the sequence. So here it was asked for the first 2. So the starting 2 instants will be the 5, 6, 1, 6, 1, 2. So at a time here the 3 devices will conduct. So in 120 degrees mode of conduction, so only 2 devices will conduct. Only 2 devices only conduct. So now let us see. What is the answer here. So here the 5, 6, 1 and 6, 1, 2 is the answer. 5, 6, 1 and 6, 1, 2 is the answer. So option D is the right answer. 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 If you want to know the reason, so let me tell you reason also, guys. So here the 6 devices are there. The first device will be here. Let it be the first device. So first device gate pulse. Second device, let me take the second device. Third device, 4, 5 and 6. Let me draw the switching pulses for this. Let me take 0 degrees here, 60, 120, 180, 240, 300 and 360. So let me divide into equal divisions. So in the 60. So 180 degrees mode of conduction is nothing but, so the switch should be conduct for 180 degrees. Each switch should conduct for 180 degrees. If each switch is conduct for 180 degrees, so how it would be? So it would be like this. So the first switch will conduct for 180 degrees, right? So it is conduct for 180 degrees. The next second switch will start at, so after 60 degrees delay of the, so first switch. So it will start at here and it will conduct for the 180 degrees. 60 plus 180, 240. So this instant would be the 240, right? So after 60 degrees, third device will conduct. So here the third device will conduct. So it will conduct for the, so 300 degrees. So after that, so after 180 degrees, after 60 degrees it will conduct. So it will conduct up to 360 degrees. So it is the third device and it is the fourth device. For example, if I want to give the pulse for the fifth device, so it should start at 240 degrees. So it will conduct for here 2 divisions. So one more division it will conduct here. So for the sixth device, so how it would be? So the reason behind this is this one. So the sixth device will be, it will start at 300 degrees. So and the remaining 2 divisions will be, so here. So now from this we can find, So if you forget this logic, so you can find from the basics. So here if you observe, so which of the devices are conducting during starting? So the one device will be high, and here, so after that fifth device will be high, so after that sixth device will be high. So the starting sequence will be the 5, 6, 1. Right? So what is the next sequence? So 1 is still is in on condition, 60 to 120. So the next device will be the 2 is in on condition, still the 6th device is in on condition. So it will be the 6, 1, 2. So it is simple, guys, it is simple. So or else if you remember this, that is sufficient. So at a time in 180 degrees, 3 devices will be in the conduction state. So the starting sequence would be 5, 6, 1, and here the starting sequence would be the 6, 1. So if you remember that, that is sufficient. So let us move to the next question, guys. Let us move to the next question. So what is this question? This one we have already discussed. What is the answer for this? So answer this question, guys. In a 3-phase inverter with 180 degrees, with 180 degrees conduction mode, the number of the switches that is on at any instant of time. So what is the answer, guys? So we have already discussed. So what is the answer, guys? So what is the answer for this? So the number of switches during 180 degrees conduction mode, how many switches are conducting at any instant? How many switches are conducting? The question is simple. How many switches are conducting at any instant? Arpit Singh, C, that we have already discussed. 6, the starting sequence of the 180 degrees mode of conduction is 6, 5, 1. If it is 6, 5, 1, so this will be the 3 devices, right? These are 3 devices. So at any instant, these 3 devices will be conducted. C is the right answer. Yes, Dhananjay, C is the right answer. Saloni, 3 is the right answer. So let us solve the next question. So which is easy question, right? So let us increase the difficulty level. So what is this question? So what is the answer for this? What is the question here? So here the single pulse modulation of the PWM inverter has taken. So we need to eliminate the 5th harmonic. What should be the pulse width? So we need to eliminate the 5th harmonic. So we need to make the 5th harmonic as 0. V0 5 as 0. The output voltage 5th harmonic component should be equal to 0. So 5th harmonic component should be equal to 0. So we are using the single pulse PWM, guys. Single pulse PWM. How we can eliminate the 5th harmonic? So what should be the pulse width? So what they are asking, just see. Guys. So in a single pulse PWM, so the output voltage would be like this. Let it be the V0. So the output voltage would be like this. So this pulse width we need to find to eliminate the 5th harmonic. Let it be the D, and let it be the alpha here, and pi here, and pi minus alpha. So no need to remember the formulas, guys. So if you know this, if you know the Fourier series of this one, that is sufficient. So it will hardly take less than a minute. So what is the D here? So answer B is the right answer. So how we have find? Let us see here. So if you observe here, if I write the Fourier series for this, so V0 equal to sigma n equal to 135 to infinity, 4, let it be the Vs here, 4 Vs by n pi into cos n alpha into sin n omega t. To eliminate the nth harmonic, this cos n alpha should be 0, right? If I make the cos n alpha equal to 0, So nth harmonic will be 0, right? Cos n alpha should be 0. Cos n alpha should be 0. When it will be 0? So it will be the cos k pi by 2. All the odd values of k. Cos k pi by 2. K is the 1, 3, 5 and so on. Right? So 1, 3, 5 and so on. So alpha should be, so n alpha should be k pi by 2. K into pi by 2. K into pi by 2. So here, so we need to eliminate the fifth harmonic. If I want to eliminate the fifth harmonic, what is the alpha here? So what is the alpha here? So k pi by 2 divided by n. So k 90 degrees divided by pi by 2 is nothing but 90 degrees. So n is given as, here we need to eliminate the fifth harmonic, right? So let me eliminate the fifth harmonic. So 90 by 5. So which is nothing but k into 18. K into 18. So the fifth harmonic will be eliminated. So for these alpha values, if I choose the 18 degrees, so we need to find the d here. D is nothing but, so here from here to here it is alpha. So from here to here it is alpha. D equal to pi minus 2 alpha. Pi minus 2 alpha. So pi minus 2 alpha is the d. So pi minus 2 alpha is the d. So if you find the d value, alpha value you can find. So k can be 18. So to eliminate the nth harmonic, fifth harmonic, k can be used as 18 or 36. So 3 into 18, 54. We can take the 54. So we can multiply with the different things. So let me take the 18. So if I take the 18, so what I will get? So 180 minus 2 into 18. 180 minus 2 into 18. So what is the answer here? 180 minus 2 into 18. So 144 degrees. If I choose the 144 degrees also, I can eliminate the fifth harmonic. But I never find the option. I never find this answer as in solution. Now let us take the k value as 3. K value as 3. If k value is 3, I will get the 54. So now, so d equal to k value as 54. So that is 180 minus 2 into 54. So 180 minus 2 into 54. So which is the 72 degrees. So option B is the right option. Option B is the right option. So no need to buy out the formulas and all. So if you know the basic concept, that is sufficient. It will take less than a minute. Dhananjay, B is the right answer. Gaurav, B is the right answer. Vishnu, Vicky, B is the right answer. So let us solve the next question. Guys. Let us solve the next question. Let us solve the next question. So it is a previous GATE question, but this question will help you to solve remaining questions also. Let me give the generalized idea for this. So first let me give the what is this question. Let us see what is this question. So let us see what is this question. So in the three-phase inverter, so it is operating in the 180 degrees mode of conduction. So we should be noted that. So 180 degrees mode of conduction, all the switches are idle. So VDC is given as 300. So we need to find the RMS value of the phase voltage. And what we have to find here? So we need to find the power consumed by the three-phase load. So RMS load voltage as well as power we need to find here. So now let us see. So generalized analysis. So even the data is varied, even the data is altered. So you must be able to solve the questions. Let us see how it is. So for example, it is 180 degrees mode of conduction. Let me take the 180 degrees mode of conduction here. So 180 degrees mode of conduction. So there are two types of conduction, right? So there is one more conduction which is 120 degrees mode of conduction. So 120 degrees mode of conduction. If I find the line voltage, VL is the line voltage. So line voltage would be the VDC into root of 2 by 3. VDC into root of 2 by 3. So input voltage into root of 2 by 3. So here for 120 degrees mode of conduction, it will be the VDC divided by root 2. If I want to find the phase voltage, how I can find? If I want to find the phase voltage, if it is star connected, I need to take VL by root 3. If it is delta connected load, take the VL. Take the VL. So VL equal to V phase. If it is delta connected, so VL equal to V phase. So this is for VL we have found. Similarly, so let me take the VL1. So what is VL1 here? So VL1 is nothing but fundamental line voltage. If I find the fundamental line voltage, so it will be the root 6 by pi into VDC. Root 6 by pi into VDC. So now if I find the VL1 in the 180 degrees conduction mode, it will be the root 3 into VDC divided by root 2 into pi. So if I want to find the V phase 1, so how I can find? So if I want to find the V phase 1, so for star connected load, so it will be the VL1 by root 3. For delta connected load, so VL1, V phase equal to VL1. If you know these formulas, you can solve for the star connected as well delta connected so easily. So now let us solve the problem. Now it is simple. Let us solve the problem. Now it is simple. Let us solve the problem. So now let me find so this answer here. So now we need to find the RMS load voltage. So line voltage equal to, we know that line voltage equal to VDC into root of 2 by 3. So now let me find the line voltage first. So the line voltage would be 300 into root of 2 by 3. So what is the answer here? 300 into root of 2 by 3 is root of 2 by 3 into 300. So which is the 244.9. But they have asked about the RMS load voltage. Here the load is star connected. So because it is a star connected, so I need to take the VL by root 3. If I take 244.9 divided by root 3, so so what is the answer here? So it will be the 141.42. So the answer for first bit is B. Now let us solve the next one. The power consumed by the three-phase load. So how we can find the power consumed by the three-phase load here? 3 into, so three-phase power equal to 3 into V phase square divided by R. So divided by phase resistance. So 3 into V phase square divided by, so the R value is given as, so in the problem R value is given as 10 ohms. So R value is given as 20 ohms. So if R is 20, so it is 3 into 141.42 whole square divided by R value is 20. So R value is 20. So which is equal to 3 kilowatts. So the option D is the right option. So option D is the right option. So for this problem, Dhananjay, I will cover all the topics in YouTube. I will take all the topics. So already devices has almost, it is in the devices portion almost more than 50% has covered. So the DC to DC converters also started. So introduction to DC DC converter is completed. Just watch that video. So for the remaining lectures, you can follow the YouTube. If you follow the YouTube, that is sufficient. I will solve more number of questions. So I will discuss each topic in detail. So follow the YouTube classes, that is sufficient. Dhananjay Mardana. Right. Let us solve the next question, guys. Let us solve the next question, guys. Answer this question. Try to answer this question. Try to answer this question. Try to answer this question, guys. Respond to this question. Let us simplify this question too. So what is the answer for this question? What we have to find? Let me explain what is the question here. Before that, let me explain what is the question. So the question here it is inverter. So operating in the bipolar modulation, operating with the bipolar sine PWM. So what is the output voltage? The output voltage waveform is as shown in the figure. So it is the output voltage waveform V0. So it is a VDC or VS. Let us take the VS. So it is minus VS. As shown in the figure, the value of alpha 1 is 15 degrees. Alpha 1 is given as 15 degrees. Alpha 2 is given as 45 degrees. Alpha 2 is given as 45 degrees. Alpha 3 is given as 60 degrees. Here in this waveform, if you observe, 3 number of notches are there. So the first notch will be the alpha 1. So the alpha 1 is given. And the second notch is given as alpha 2. And the third notch will be the alpha 3. So we have 3 notches in the quarter cycle. So how to find the fundamental voltage? Did anyone got answer? So let me explain, guys. Let me explain the concept. After that, you can solve easily. So it is easy problem. No need to worry here. So it is easy problem. So now let us see. Let me explain clearly. So this is the voltage waveform we have. For the bipolar voltage, let me give the generalized formula. So whatever be the notches, here the 3 notches is there. See, if they have given 5 number of notches also, no problem. Let us see here. So what is the generalized formula? Let us see. So the generalized formula for this is, so V0 equal to 4 Vs by n pi sigma n equal to 135 to infinity, because it having the quarter wave symmetry. So n equal to 135 to infinity, 4 Vs by n pi into, so 4 Vs by n pi into, so 1 plus sigma I equal to, so 1 plus 2 into, let me write here, 2 into sigma I equal to 1 to n, k, let it be the k, 1 to k. So minus 1 power I into cos n alpha I. Let me explain what it is. So don't get confused. Let me explain what it is. So let us see the shortcut also. So now at this stage, so for this waveform, so this is the Fourier series and this is the Fourier series. So what is the I here? I is nothing but, so I is varying from the 1 to k, right? So I is nothing but number of notches per quarter cycle. Number of notches per quarter cycle. So the first time it is difficult to get. So after that you will directly write the expression. Let us see how it is. So I is varying from 1, 2, 3, right? So because here 3 number of notches are there. So what does it mean? If you observe, the pi by 2 instant is here. So before that, if you observe 1 notches, 2 notches, 3 notches. So 3 crossover points are there. So let me call it as a notches. So here the 3 notches are there. They are alpha 1, alpha 2, alpha 3. So there are 3 different angles are there. So I equal to 1, 2, 3. So if I substitute I equal to 1, 2, 3 in this expression, so I will get the answer. So n equal to 1. So here we need to find the fundamental RMS output voltage. Let me substitute n equal to 1. So V0 1 equal to, if I substitute n equal to 1, so what happens? 4 Vs by n pi. In place of 4 Vs by n pi, so 4 Vs by pi into 1 plus 2 into minus 1 power 1. So first let me substitute I equal to 1. So if I substitute I equal to 1, what happens? Minus 1 power 1 equal to minus 1. So that it will be the minus 1. So 1 minus 2 cos alpha 1, right? 2 cos alpha 1. So 2 cos alpha 1. So plus minus 1 power 2. If I substitute the I equal to, what happens? If I substitute the I equal to, it will be the minus 1 power 2. Minus 1 power 2 is the 1. So it will be the plus 2 into cos alpha 2. If I substitute the, so in place of I, if I substitute the 3, what happens? minus 1 power 3. So it will be the minus 2 cos alpha 3. Minus 2 cos alpha 3. So this one we need to find. This one we need to find. So now, so this one we need to find here. So divided by root 2 we need to take because it's a maximum value. So they have asked for the RMS value, so that I need to take the divided by root 2. So what is the shortcut here? So here for alpha 1, for the odd values, we need to take the minus sign. For even values, we need to take the plus sign. So it will be the common. It will be the common. It won't change. 4 Vs by, so n pi will not change. So but here what will be change? So here it will be change 1 minus. So for odd values of notches, we need to take the minus sign. For even value of notches, we need to take the plus sign. That's it. So now let us take Vs equal to 100. So let us take the Vs equal to 100. So if Vs equal to 100, find the output voltage for this. Find the fundamental output voltage for this. Find the fundamental output voltage V01. So V01 equal to 4 into 100 divided by root 2 into pi. Root 2 into pi. So 1 minus 2 cos alpha 1. Alpha 1 value is 15 degrees. Alpha 1 value is 15 degrees. So plus 2 cos alpha 2. Alpha 2 value is 45 degrees, I think. So it will be the alpha 2 will be. So what is alpha 2? So alpha 2 is 45 degrees. Alpha 2 is 45 degrees minus 2 cos alpha 3 is the 60 degrees. 60 degrees. If you know the concept, it will take less than a minute. So it is easy, guys. It is easy for number of notches. So what is the answer, guys? Minus 46.6. Minus 46.6. Minus 46.6 volts. Arpit Singh, you are right. It will be the minus 46.6 volts. Everyone complete this problem. So it is easy, guys. Just follow the steps. So it is easy. So for whatever be the number of notches, for example, if one more notch is there, alpha 4 is there, we need to add the plus 2 cos alpha 4. That's it. So this is the output voltage waveform for the bipolar sinusoidal PWM technique. So sinusoidal PWM inverter. So let us solve the next question. Let us go to the next question, guys. Let us solve the next question. Let us solve the next question. Let us solve the next question. Let us solve this question. So let us solve this question, guys. So what will be the answer? What will be the answer here? So let us solve this question. What will be the answer? Let us solve this question. Minus 46.6 is the right answer, guys. So let us solve this question. What is the answer for this? So there are 4 options are there. Let me mention the options A, B, C, D. So what is the answer for this? So very easy question. It comes under difficulty level as low. It comes under difficulty level as low. So previous problem we can put it in the medium, but so this is very low. Difficulty level is very low. So here what we have to find? So here they have given the switching pulses here, S1, S4 and S2, S3. Switching pulses for the S1, S4 and S2, S3. So here the switches are S1, S4 switches here, S2, S3 switches will be here, right? So here for that switching pulses, the current is, if the load current is sinusoidal, assume load current is sinusoidal. So here the load current is sinusoidal and it is 0 at 0 point pi 2 pi. So 0 pi 2 pi. It is 0 at, this current is 0 at, so 0 instant, pi instant as well as 2 pi instant. For that what we have to find? So we need to find VA naught. So VA naught. So VA naught is nothing but this pole voltage we need to find. We need to find the VA naught. So which waveform will satisfy the VA naught? Which waveform will satisfy the VA naught? Find this VA naught, guys. Answer this question. We need to find the VA naught. We need to find the VA naught here, that is pole voltage. Is that much difficult? It is very easy question, guys. Don't take too much time, it is very easy question. So let me explain once, otherwise let me explain once. So let me explain once. Let me explain once. So let me explain once. So now let us take the switching pulses here. Let us take the switching pulses here. So let me draw the load current first. Let me draw the load current. So what is the load current here? So what is the load current here? So load current is given as sinusoidal. Load current is given as sinusoidal. So which is in the sinusoidal nature. So which is in sinusoidal nature. It is 0 at 0 and it is 0 at pi and it is 0 at 2 pi. And it is 0 at 2 pi. So for this, so we need to draw the output voltage. We need to draw the output voltage. Now let us see. So here at theta to pi minus theta, let me keep the theta here. At theta to pi minus theta, what happens? Theta to pi minus theta, the switches S1 and S4 is in on condition. The switches S1 and S4 is in on condition because we are giving the triggering pulse to the S1 and S4. So the switches S1 and S4 is in on condition. S1 and S4 is in on condition. So when S1 and S4 is in on condition, so what about the output voltage? So the output voltage is positive. So when S1, S4 is in on condition, when these two switches in on condition, the output voltage is positive. So now let me draw the output voltage as positive here. Positive here. So because S1, S4 is in on condition, let me mark the pi plus theta and 2 pi plus theta. 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 So what happens here? So during that time, so the S1, S2 and S3 for switches will be on condition. So S2 and S3 are in on condition. When S2 and S3 is in on condition, what happens? When S2 and S3 is in on condition, the output voltage is negative. That is clear. The output voltage is negative. So VA naught equal to VDC minus VDC by 2. So now we got so output voltage is positive for that one. So output voltage will be negative for this one. So if the current is positive here, so what are the conditions when the current will be positive, but these devices are not conducting? So that at that time, what is the thing here? So here the current is flowing from 0 to theta. If you observe, from 0 to theta, the current is positive, but neither of switches are in conduction state. Neither of the control switches are in conduction state. So but the current is flowing in the circuit. How this current will be flow? So for example, if I take the D3 and D4, so what happens? If I take the D3 and D4, if I take the D2 and D3 here, D2 and D3, so what happens? The current will be positive. How the current will be? The current will be, so in this direction. The current will be in this direction. The current will be in this direction. So current is positive if I close the D3 and D2, D2 and D3. So if I close the D2 and D3, the current is positive, but what about the output voltage? Output voltage is negative. When D2, D3 are in on condition, the current is positive, I is greater than 0, but output voltage is negative. Similarly, if the D1 and D4 is in on condition, D4 is in on condition, what happens? D4 is in on condition. If D1 and D4 is in on condition in this, so D1 and D4 is nothing but this one and this one. So when these two switches in on condition, the current will flow in the opposite direction. So that I naught is less than 0 I naught is less than 0 and V naught is greater than 0. V naught is greater than 0. So from this we should conclude that if the diode D2, D3 are in on condition, if the diode D2, D3 are in on condition, I naught is greater than 0, but V naught is negative. If the diode D1, D4 is in on condition, so I naught is less than 0 and V naught is greater than 0. From this analysis, let us find. So here the switches are given, they are controllable switches. When we are giving the firing pulse to the switches, so only during that time the switches will be in the on condition. So remaining all these times, the switches are in the off condition. The switches are in the off condition. But still the current is flowing to the diodes. So what is the combination there? So either D1, D4 has to be conducted or D2, D3 has to be conducted. But which devices are conducting depends on the current waveform. Here if you observe here, from 0 to theta, the current is positive. If the current is positive, so which device will conduct? So which devices will conduct? D2 and D3. So here D2 and D3 will conduct. If D2 and D3 is conducting, so what about the output voltage? The output voltage will be like this. The output voltage will be negative. So for example, so if you observe here, again current is positive from here to here. If the current is positive, so which devices will conduct? D2 and D3. If D2, D3 are in conduction state, so what about the output voltage here, from here to here? So it will be the D2, D3. So right? So from here to here, the current is positive, so the devices will be the D2 and D3. So again it will be the negative. So here the negative, current is negative, the diode D1 and D4 will conduct. So it will be the positive. Again here current is negative, but neither switch of the neither controllable switches are in conduction state. So only diode has to be conducted. So that diode should be the D2 and D4. So now again it will be the positive. So this is the output voltage waveform. So if you know the concept, it is very easy. So for this problem, we should know that which of the devices are in the conduction state. So now, option D is the right option. For this, option D is the right option. Raj Gaurav, option D is the right option, not option A. Saloni, so refer once. So it will be the option D. So option D. Because the current is not going to be 0 in remaining instants. The current is flowing. So here the controllable switches are in the off condition during these periods. But the diodes has to be conduct to carry that current. Raj Gaurav, option D is the right answer. So let us solve the next problem. Next Mira. Who is next? Sir, EMFT. So this is all for today, power electronics guys. So these sessions will be continued by the EMFT sir. So Chaitanya sir. So just wait for a few minutes. Sir will join. So thanks for listening guys. So if you have any doubt till now, you can ask. Tomorrow we'll discuss few more questions. Conceptual questions. Thanks for listening the lecture. So if you have any doubt, you can ask guys. So if you are getting the doubts means you are listening. So if you are not getting any doubt means you are just following the lecture. Ask more doubts in the session, because it's a live session, you can get the answers. So okay guys, next session will be handled by the Chaitanya sir. Just wait for a few minutes, he will join.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
And battle it out with a test.
To bring out the best in you.
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
And battle it out with a test.
To bring out the best in you,
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Gamified.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you,
Unacademy Combat is the most competitive gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello everyone, welcome back to the session. Is my video and audio clear, dear? Just confirm the video and audio once. We'll continue with EMF questions. Yes, thank you. For a plane traveling EM wave, the correct equation for characteristic impedance Z for the medium with permittivity epsilon and permeability mu is characteristic impedance for a given medium is nothing but the intrinsic impedance for free space. Both are alternate terms. Both represent the same thing. So what is intrinsic impedance or the characteristic impedance? Eta, or for any given medium it is Z, is under root of mu by epsilon. Under root of mu by epsilon. That is option A is the answer. Is that clear? Quickly share the session, dear. Everyone quickly share the session. Next question. The velocity of electromagnetic waves in free space is given by. The velocity of electromagnetic waves in free space is given by. Velocity is 1 by under root of mu epsilon. For free space, mu is mu naught. Epsilon is epsilon naught. Therefore, velocity is given by 1 by under root of mu naught epsilon naught. Once you evaluate this, you get velocity of light in free space. 3 into 10 power 8 meter per second. For V is equal to C. The formula is 1 by under root of mu naught epsilon naught. Therefore, option C is the answer. Okay. The next question, the depth of penetration of a wave in a lossy dielectric. Lossy dielectric means good dielectric. The depth of penetration of a wave in lossy dielectric increases with the increasing of what? Conductivity, permeability, wavelength or permittivity. Read the question carefully. There's a small twist in this question. So read the question carefully and answer. Is asking for the depth of penetration. Is asking for depth of penetration. Delta. You know, depth of penetration, delta is related to alpha as delta is equal to 1 by alpha. What is depth of penetration? How to understand depth of penetration? For a wave propagating in any given medium, the electric field is given by E is equal to E naught into e power minus alpha z. For example, the wave is propagating in z direction, e power j omega t minus beta z. Example, the electric field is along x direction, that is Ax. This is representation of electric field for a wave propagating in z direction, where omega t gives the change of phase with respect to time. Beta z gives you the change of phase with respect to space. You know, for any wave, a wave is one where the phase changes with respect to time and space. Now this is all the phase term. In calculation of penetration depth, we only need amplitude term. The amplitude term is E naught into e power minus alpha z. At z is 0 initially, amplitude of electric field is E naught, at z is 0. Now once at z is equal to delta, it has travelled a distance of delta, then what happens? E is equal to E naught into e power minus alpha z. Z is delta, e power minus alpha delta. But you know, alpha into delta is 1 or delta is 1 by alpha. This value is 1. Therefore, what do you get here? E naught into e power minus 1. What I am getting here is E is equal to E naught into e power minus 1. E is equal to E naught into e power minus 1. Or E is E naught into 1 by E. E is 2.718. 1 by E is 0.368. If E is 0.368 of E naught. So what is penetration depth now? Penetration depth is the distance travelled by the wave such that its initial amplitude is decreased to 36.8%. This is called penetration depth. For a good dielectric, the penetration depth, delta, as you know, it is 1 by alpha. How to understand the penetration depth here? It depends on which quantities. How to understand? For that, you should understand the value of alpha. How much is alpha for a good dielectric? For a good dielectric, alpha is sigma by 2 into under root of mu by epsilon. For a good dielectric, lossy dielectric or a good dielectric, alpha is sigma by 2 into under root of mu by epsilon. I'm right. This is the value of alpha for any good dielectric. Now he is saying that the given case is a lossy dielectric. There are losses. That means there is a conductor. If you consider the conductor, for any given conducting medium, alpha is equal to under root of omega mu sigma by 2. Delta is 2 by under root of omega mu sigma. Delta, I'll take it on a fresh page. Alpha is under root of omega mu sigma by 2. Delta is 1 by alpha. Delta is under root of 2 by omega mu sigma. That is, delta is 1 by under root of omega is 2 pi f. So pi f mu sigma. Pi f mu sigma. Arpit is going for D. The depth of penetration delta increases with the increase of what? Increases with the increase of what? Now the question here is, are you going to take the good conductor or a good dielectric? I told you two cases. For this, delta is 2 by sigma under root of epsilon by mu. Under root of epsilon by mu. If sigma increases, conductivity, first one. If conductivity increases, delta decreases, it does not increase. If permeability increases, it also decreases. Wavelength, it is independent of wavelength. Permittivity, if permittivity increases, delta increases. Now, the trick here is, whenever he is saying lossy dielectric, you must take that it has a good dielectric, but not a good conductor. That's the twist. That is what the people will think. See here. If I take good conductor, given that it is a good conductor, then this is the formula. This is for good conductor. For example, if the question is for good conductor, then what is the answer? Tell me. If the question is for good conductor, delta increases. Delta increases. If mu decreases, conductivity decreases, or frequency decreases, or wavelength increases. In this case, delta increase with wavelength, because given that it is a good conductor, if the same question is for good conductor, delta increases with wavelength. Answer will be wavelength. Answer will be C, wavelength. But given it is a good dielectric or a lossy dielectric or a good dielectric, the answer will be epsilon. Got it? Yes, Arpit, Vikash. You need to understand this difference very carefully. We need to understand this particular difference very carefully. For a good conductor, delta increases with wavelength. For a good conductor, delta increases as wavelength increases. For a good dielectric, delta increases as permittivity increases. Any doubt? Is that clear? Next question. Arpit, Vikash, Please note down both the cases, dear. You please note down both the cases. Next one, for an electromagnetic wave incident on a conducting medium, the depth of penetration is, for any given conducting medium, delta is equal to 1 by alpha. They are inversely related. They are inversely related. The depth of penetration delta is directly proportional to attenuation constant, is inversely proportional to attenuation constant, has a logarithmic relationship with the attenuation constant, is independent of attenuation constant, is inversely proportional to attenuation constant. Question number 72, option B is the answer. Clear? If the frequency of a plane electromagnetic wave increases by 4 times, if the frequency increases by 4 times, the depth of penetration when it is incident normally on a good conductor, see here mentioned good conductor, on a good conductor, when is incident on a good conductor will be increasing by the factor of 2, decreases by a factor of 4, remains same, decreases by a factor of 2. You know, depth of penetration delta is 1 by alpha, which is under root of 2 by omega mu sigma. Delta is under root of 2 by omega mu sigma. Solving this, this is under root of 2 by 2 pi f mu sigma. Delta is 1 by under root of pi f mu sigma. Therefore, delta is proportional to 1 by under root f. Delta is proportional to 1 by under root f. As frequency increases, delta decreases. For higher frequencies, we have very less penetration depth. This very less penetration depth is called as skin depth. At lower frequencies, delta increases. You have high penetration depth. Now, as the frequency increases by 4 times, as you know, delta is proportional to 1 by under root f. It is proportional to 1 by 2. It becomes half of the previous value. Decreases by a factor of 2. Therefore, question number 73, option D is the answer. Question number 73. Option D will be your answer. Clear? The amplitude of electric field intensity on the surface of a good conductor this is a good conductor. The amplitude of electric field intensity on the surface of good conductor is E naught. The amplitude of the field at the depth equal to skin depth is, when it has traveled a distance of delta, What is the amplitude here? As explained in the previous question, E is equal to E naught into e power minus alpha z e power j omega t minus beta z for a wave propagating in z direction with electric field along x direction. This is phase term. When it travels a distance of delta, this will become E is equal to E naught into e power minus alpha delta. Alpha is 1 by delta, they cancel out, e power minus 1. E is equal to E naught into e power minus 1, which is 1 by E. E is 2.718 as explained in the previous question. It is 0.368. Therefore, the amplitude will become 0.368 of E naught or 0.36 E naught approximated. Question number 74, option B is the answer. Is that clear? Yes, dear. Is it clear? Yes. Next question. Pointing vector of a plane electromagnetic wave traveling in a medium represents. The pointing vector of a plane electromagnetic wave traveling in a medium represents. What does pointing vector represent? What does pointing vector represent? Pointing vector always represents power density. The pointing vector, if you take the average pointing vector for suppose is 1 by 2 real part of E cross H conjugate. Formula is 1 by 2 mod E mod H. Electric field is volt per meter, magnetic field is ampere per meter. This is volt per meter, this is ampere per meter. This is watt per meter square, which is power density. Therefore, question number 75, option B is the answer. Identify the correct statements. Pointing vector, its direction indicates the direction of power flow. Pointing vector, its direction is normal to the plane containing E and H. Pointing vector is particularly useful for calculating power flow of electromagnetic wave. All the above. Identify the correct statements. Each of these statement is true. Pointing vector and its direction indicates the direction of power flow. True. Pointing vector direction is normal to the plane containing E and H because P is equal to E cross H. The pointing vector will be normal or perpendicular to the plane containing E and H. It will be in the direction of propagation of wave. Pointing vector is particularly useful in calculating the power flow of electromagnetic wave. True. All the above. All the above. Yes, because all the above. Identify the correct statements. The angle of incidence at which the reflection coefficient becomes 0 if the wave is parallelly polarized is called Brewster angle. According to definition, Brewster angle is the angle of incidence for which reflected wave is 0, but defined only for parallelly polarized waves. By definition, statement number 1 is true. There exists an angle of incidence at which reflection coefficient becomes unity. This is called as critical angle. According to definition, critical angle is the minimum angle of incidence. The critical angle is the minimum angle for which total internal reflection takes place, and the critical angle is measured at the core cladding interface. At the core cladding interface, that is how you try to define in optics. And how do you define here? You define that the critical angle is measured between the interface of two mediums. So critical angle is measured with the normal to the interface of two mediums, and critical angle is the minimum angle for which total internal reflection takes place. Therefore, at critical angle, incident wave is equal to reflected wave. Therefore, reflection coefficient, which is reflected wave by incident wave, is 1. Therefore, by definition is also true. So both A and B are true. Option C is the answer. Clear? Try to do this. Yes. Maybe sometimes. Consider a scalar function V given in cylindrical coordinate system. The coordinate system is cylindrical coordinate system. The potential function given is, or the scalar field given is 5 rho square sine 2 phi. 5 rho square sine 2 phi. Laplacian of V at rho is equal to 1. Laplacian of V del square V. At rho is equal to 1. Phi is pi by 2 and Z is 0 is. How to calculate Laplacian? How to calculate Laplacian? How to calculate Laplacian here? Del square V is del dot del V. Del V is called gradient of that particular scalar. How to give gradient? First give gradient. Gradient is 1 by H1 dou V by dou U of AU 1 by H2 let me take K here, okay. Del square of K is del dot del K. Del square of K is del dot del K. Del K gradient 1 by H1 dou K by dou U of AU 1 by H2 dou K by dou W dou K by dou V of AV plus 1 by H3 dou K by dou W of AW. This is the formula for the gradient. What is the formula for the divergence? Because gradient of any scalar is a vector, so divergence is given as del dot A. Let del K, the gradient of scalar is a vector, then del dot A is 1 by H1, H2, H3 dou by dou U of H2, H3 AU plus dou by dou V H1, H3 AV by dou W H1, H2 AW. That's del dot A. Now, how do you write del square of V or del square of K? Del square of K is del square of K is del dot del K. Del K is nothing but A. Okay, so replace 1 by H1, H2, H3 of dou by dou U H2, H3 of AU. What is AU here? This one. AU is that one. 1 by H1 of dou K by dou U. So by H1 of dou K by dou U plus dou by dou V H1, H3. What is AV? AV is this. By H2 dou K by dou V plus dou by dou W H1, H2 of AW 1 by H3 dou K by dou W. This is in cylindrical coordinate system. So what are H1, H2, H3? What are H1, H2, H3 here? In cylindrical coordinate system, scaling factor H1 is 1, H2 is rho, H3 is 1. Substituting del square of K is 1 by H1, H2, H3, 1 by 1 into rho into 1, 1 by rho of dou by dou U, that is dou by dou rho of H2, H3, rho into 1, rho by H1, 1 of dou K by dou U. Dou K by dou U is dou rho. What is K here? Scalar function. Here the scalar function is 5 rho square into sine 2 phi. 5 rho square into sine 2 phi. 5 rho square into sine 2 phi plus dou by dou phi h1 h3 1 into 1 by h2 1 by rho of dou by dou phi of k 5 rho square sine 2 phi plus dou by dou z plus dou by dou z h1 h2 1 into rho by h3 that's 1 into dou by dou z of phi dou by dou z of k value 5 rho square sine 2 phi dou by dou z of 5 rho square sine 2 phi. You know this is, if you can see here, there is no z term. Therefore, anyone got the answer? No. If you can see here, there is no z term. This will become 0. Del square k is 1 by rho of dou by dou rho times derivative of 5 rho square sine 2 phi 5 sine 2 phi into 2 rho dou by dou rho of 2 rho square into 5 sine 2 phi plus dou by dou phi of 1 by rho of 5 rho square sine 2 phi derivative 5 rho square cos 2 phi into 2, that is 10 rho square cos 2 phi. This is del square k is 1 by rho of 10 sine 2 phi into dou by dou rho of rho square, that's 2 rho into 2 rho plus dou by dou phi of cos 2 phi. This rho one time get cancelled plus 10 phi plus 10 rho derivative of cos 2 phi minus sine 2 phi into 2 into sine 2 phi minus, this is 20 rho sine 2 phi minus 20 rho sine 2 phi. This value will become 0. So the Laplacian of that scalar function will become 0. So what's the answer? Option B is the answer. Question number 78, option B is the answer. Is it clear? Question number 78, is that clear? Next question. Find the Laplacian of the scalar function u is equal to rho square z cos 2 phi. Yes, same practice problem, same. Do it. Now Laplacian directly I'll write. del square of k, let this be k. Del square of k is 1 by h1, h2, h3, 1 by rho of, same formula as previous question, okay? 1 by h1, h2, h3, dou by dou u, that is dou by dou rho, h2, h3, that is rho into 1, h2, h3, then h2, h3 by h1, that is 1, dou k by dou rho, dou by dou rho of k, rho square z cos 2 phi. Plus dou by dou v, that is dou by dou phi, h1, h3, that is 1 by h2, 1 by rho of dou by dou phi of k value, rho square z cos 2 phi. Plus dou by dou z plus dou by dou z dou by dou z of h1, h2 rho times by h3 dou k by dou z. Now if you see carefully, if you do one time derivative for this z will become 1. You get rho square cos phi, rho square cos 2 phi into rho cube cos 2 phi. When you do the second time derivative, there is no z term. Therefore this one will become 0. The third term will become 0 anyways. So you can neglect. Yes, Arsha, do it. Okay. Now solve this. Del square k is 1 by rho of dou by dou rho, dou by dou rho of rho times dou by dou rho of rho square z cos 2 phi, that is 2 rho z cos 2 phi, 2 rho square z cos 2 phi plus second term dou by dou phi of cos 2 phi minus sin 2 phi into 2. So you get minus dou by dou phi 1 by rho of dou by dou phi of this rho square, I am writing outside, rho square by rho z sin 2 phi into 2, minus will come out. This is 1 by rho of dou by dou rho of 2 rho square z cos 2 phi is 4 rho z cos 2 phi, 1 by rho of 4 rho z cos 2 phi minus dou by dou phi of rho square by rho, this is rho z right outside, 2 rho z out right outside, derivative of sin 2 phi cos 2 phi into 2 into 2, that is 4. First term 4 rho z cos 2 phi, second term 4 rho z cos 2 phi, again the value will become 0. Therefore option C is the answer. Got it? And special classes are not started yet. I was busy with marathon. Most probably from Tuesday I'll start, Harsha. Most probably from Tuesday we'll start, okay? The divergence of the vector field, V is equal to x square ax plus 2y cube ay z power 4 az. At x is 1, y is 2, z is 3 is. At x is 1, y is 2 and z is 3 is. Solve it. He's asking us to find the divergence of the vector field. Clear? Yes, dear, share among all our friends. Harsha. This is V, x square ax plus 2y square, 2y cube ay plus z to the power of 4 az. Divergence of the vector del dot V is dou by dou x of x square 2x plus dou by dou y of 2y cube 6y square plus dou by dou z of z to the power of 4 4z cube. X is 1, y is 2, 2 square 4 into 6 24, z is 3 3 cube 27 into 4 108. Therefore, the total divergence is 134. The value of divergence is 134. Very good, very good, very good. Very good. The vector, let it be A, is 1 by 3 of 2ax minus 2ay plus az is dash vector, unity vector. It is parallel to the vector minus ax plus ay minus 1 by 2 of az is perpendicular to the vector 3ax plus 2ay minus 2az. All the above. Verify. First, tell me, is it a unit vector or not? How do you tell me it is a unit vector or not? Find the magnitude of it. 1 by 3 of under root of 4 plus 1 magnitude is 1. Any vector whose magnitude is 1 is a unit vector. A is correct. Is parallel to the vector minus ax plus ay minus az by 2. We need to show that it is parallel to this particular vector. How to show it is a parallel to that particular vector? Any two vectors are said to be parallel. If you do their curl and its value is 0, then you say both the vectors are parallel. Let this be B vector. If you do A cross B, AX, AY, AZ, right, 1 by 3 outside, 2 minus 2 and 1. For B vector, minus 1, 1 and minus 1 by 2. Therefore, this is AX of 1 minus 1, that's 0, minus AY of minus 1 plus 1, 0, plus AZ of 2 minus 2, 0. Null vector. You are getting a null vector means A and B are parallel to each other. True. We need to show they are perpendicular to each other or not. If they are perpendicular to each other, let B vector is now 3ax plus 2ay minus 2az. We need to show it is perpendicular vector, then the dot product is 0. So do the dot product here. If you do A dot B, this is A vector and this is a B vector. If you do A dot B, it's 1 by 3 of 6 minus 4 minus 2, 0. So the dot product is becoming 0. We can say both the vectors are perpendicular. It is unit vector, it is parallel to this particular vector and perpendicular to this particular vector. All the three conditions are true. Therefore, option D is the answer. Therefore, option D is the answer. Yes, Manikanda, correct. Question is bit zigzag. Order has changed. I'll try to read out. This is the last question, okay? Then you'll have Hari sir dealing with mathematics with some special questions for today also. So I'll read out this question. Consider the following statements. If the divergence of a vector A is 0, let me highlight it. If the divergence of a vector A is 0, then the vector A can be expressed as a curl of a vector F. Can be expressed as a curl of a vector F. What is saying? If the divergence of a given vector A is 0, then this vector A can be expressed as curl of F. That means what? That means what? Is saying in this case I can write A as del cross F is saying. If you substitute back del dot del cross F, divergence of curl of any vector is 0. It's a vector identity. Therefore, first statement is true. A is true. Now you read from here. This is B statement. A static electric field is conservative or irrotational. Yes, static electric field is conservative. It is said to be conservative and its curl is 0. And you know, for static electric field, del cross E is 0. Therefore, second statement is also true. Option B is also true. Third statement, option C, lifting power of magnet is proportional to the radius of the coil. Lifting power of the magnet is proportional to the radius of the coil. Lifting power of the magnet, force F is equal to B square A by 2 mu. Formula for the force or the lifting power of the magnet, B square A by 2 mu. So the force is equal to or is directly proportional to the area. So it's proportional to the radius, of course. Where A is the area of the coil. Of course, then it is proportional to the radius. I'm right. So it is proportional to the radius. True. This is option C, which is also true. Last one. The magnetic field at the center of a circular coil of a wire carrying current is inversely proportional to the radius of the coil. Option D is the magnetic field at the center of the circular coil. If you take a circular coil, the magnetic field at the center, because of the circular conductor, is H is equal to I by 2A, where A is the radius of the coil. Where A is the radius of the coil. That means what? Magnetic field at the center is inversely proportional to the radius. What is given? The magnetic field at the center of the circular coil of the wire carrying current is inversely proportional to the radius of the coil. True. All the options are true. All the options A, B, C, D are true. Is that clear? So tomorrow morning, 10 a.m., we'll have 1.5 hours of communication and 1.5 hours of EMF. So most of you people who are all live, please share the session, like the session, and importantly, you share the session among all your friends so that these particular classes will reach to most of the people. With 2 minutes or 3 minutes of layover time, Hari sir will join you with mathematics subject. Thank you all. Thank you all for joining.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you,
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you.
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello everyone, good evening all. Is audio and video clear? Please confirm once. Is audio and video both are clear? Yeah, hello Rajmohan. Good evening Shekhar. Yes, audio and video both are clear, right? Yeah. In this session, we are going to discuss a very good conceptual questions from all the topics. For each and every question, we are going to see what is the formula approach and what is the conceptual approach and all. Okay, before going to start the session, let me introduce myself. I am Haribabu Ande, having 5 years of teaching experience in GATE, and my MTech is in power systems. Before joining my MTech itself, I started teaching engineering, maths and aptitude. After that, I took controls as well. You can use my code HARIMATH to get 10% off on Unacademy Plus subscription. Yes, these are the two platforms that are there in Unacademy. The first one is Plus and second one is Iconic. The Plus one is going to have features like live classes, crash courses, weekly test, doubt solving for both English and Hindi. Right? Coming to Iconic, Iconic is going to have all the features that are there in Plus. Along with that, we are going to have some personal coach and study materials and all. Right? Next, these are the pricing plans for Plus course for 12 months, 18 months and 24 months. You can use the code HARIMATH to get 10% off. HARIMATH, right? These are the pricing plans for Iconic for 12 months, 18 months and 24 months. Here also you can get 10% off by using HARIMATH code. Right? This is the new feature from Unacademy. Unacademy Ask a Doubt. You can ask at any time, you can ask the doubts, any number of times you can ask. For the doubts, we are going to have video solutions and so many question bank and all, solution bank and all, right? Yeah, these are the new batches for GATE 2022 and 2023, for ESE 2022 and ESE 2023 as well, for both electrical and ECE. For both electrical and ECE, new batch started from 1st. Yeah, these are the special classes and its features. These are the live interactive classes that are available in Unacademy app, learner app for free. In the classes, polls will be there for the learners. Okay, so the educator is going to ask the doubts, ask the questions in the form of polls where you need to respond so that the concepts will be cleared. And raise a hand. You can you can talk to the educator directly by using this option, raise a hand, and never miss a class. That means if you click follow for any educator in Unacademy learner app, you are going to get notifications whenever that educator is coming to live, right? And coming to the next one, lecture notes. You can, of course, you can download the lecture notes from the app, and anytime, anywhere you can watch. That is what the advantage of online teaching, online coaching, right? Yeah, this is the Bucks bounty. That means the most interesting thing, where the learners are going to get awarded if they find any inappropriate content. Okay, so what you need to do is, if you find any inappropriate content, just you need to report to Unacademy, so that they are going to verify and they are going to reward you, right? So let us start our discussion with this one. Good evening, Venkatesh. Good evening, Lasya. Good evening, Saloni. Try to solve this one, yes. Try to solve this one. A very good conceptual question from probability, the basics of probability. Okay, try to solve this one here. Very easy question. Very easy question. Try to solve this one here. An examination consisting of two papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3. The probability of failing in paper 2 is 0.2. Yes, 0.2. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. The probability of student failing in both the papers. Little bit trick is there. We should understand. Even though it is a basic question, we can solve this one just like that. Good evening, Prasad. What is the concept behind this question? What is the concept behind this question? So let me try to take whatever the given data is there. There is an examination is going on in which there are two papers. There are two papers, right? There is a two papers, paper 1 and paper 2. Here the probabilities are given for failing paper 1 and failing paper 2. Okay, so let me take P of F1 as probability for failing in paper 1. Okay, so the probability of failing in paper 1 is 0.3, right? Next, then the probability of failing in paper 2 is 0.2. Is it clear, guys? Right, that is what given. Now the exact thing, the exact point in this question lies in this statement. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. What is the meaning of this one? If you understand the statement properly, you can get it very easily. Right? So what is the meaning here? The probability of failing in paper 1, if already student failed in paper 2 is 0.6. This given that is having a meaning. Okay, whenever this given that is there in the question, that means that we should take as conditional probability. And we should write this one as probability of failing in paper 1. The student has already failed in paper 2 is P of F1 by F2 is equals to 0.6. Right? Now, what is the question asking? The probability of student failing in both the papers. Both means intersection. That means P of F1 intersection F2 we need to find. Okay, this is the complete given data. I hope the question is clear now, I think, right? Now tell me, which formula we have to use or which theorem we have to use? Tell me, guys, which theorem we have to use? Yes, which theorem we have to use? We have to use multiplication theorem, right? Multiplication theorem. Based on that, we can write P of F1 intersection F2 is equals to, we can write this one as P of F1 by F2 into P of F2, right? This is the multiplication theorem on probability. So what is the value here given? P of F1 by F2 0.6 into, what is the P of F2 here? Probability of failing in paper 2, 0.2. So this is nothing but 0.12. 0.12. Right? Just we need to know this, given that in the question, and after that automatically we will come to know this question belongs to multiplication theorem on probability. Right? Saloni C is correct. Yes, Rambabu correct. Yes, why not correct? Very good. Lasya 0.12 correct. Arpit C is perfect. Yes. Now let's move on to the next question. Yeah, this is a very interesting question. This is very interesting question. Having little bit concept, if you understand this one, you can enjoy a lot. Try to give the answer for this one. Try to give the answer for this one. Try to give the answer for this question. A cubic polynomial with real coefficients. The question is having only single line. The cubic polynomial with real coefficients. Real coefficients. Right? That is what given in the question. That is what given in the question. In the options, what is given here? In options, what is given here? It is given that it is talking about extrema values and zero crossings. It is saying about extrema values and zero crossings. Extrema values, zero crossings. Okay, this question is completely about extrema and zero crossing. This question is all about extrema and zero crossing concept. Okay, we should know first of all what is meant by zero crossing and what is meant by extrema. Any answers, guys? Arpit, have a look once again. Have a look once again. This is a very good conceptual question. This is a very good conceptual question. A cubic polynomial with real coefficients. Sujini, have a look once again. Have a look once again. Yes, there are different answers from all the guys. So let me explain. So before solving this cubic polynomial, let me tell you what is meant by zero crossing, what is meant by extrema. Okay, so for that one, let me take this waveform as example. Okay, I don't know what is this waveform, but for explanation point of view, I'm taking this waveform or function, we can say, right? If you see here, these are the points 0, pi, 2 pi. Okay, the points at which the function value becoming 0, those points are called zero crossings. Here, tell me, what are the zero crossings here? Zero crossings are 0, pi, 2 pi. 0, pi, 2 pi. These are the zero crossing points, right? Coming to extremas, extrema values means, see here, this one we can take one of the extrema value, okay? Local extrema or local maximum, local minimum, whatever we can take, they will comes under extrema values. Okay, so this one is also one of the extreme value. This one also one of the extreme value, right? So this is what meant by zero crossing and extremas. Now try to tell your answer now. Try to tell me your answer now. Yes, I hope first of all you guys understood what is meant by zero crossing, what is meant by extrema, right? Yeah, good evening, Burning. Try to solve this problem. See here, what is given here? Let me take y is equals to f of x, which is a cubic polynomial. Let me write this one as a0 x cube plus a1 x square plus a2 x plus a3. Plus a3, right? This is what cubic polynomial as per the question. One more thing given is all the coefficients are real. Okay, fine. Okay, so what we need to find is first of all zero crossings. Zero crossings is easy to find. See, wherever this function is becoming zero, such values are called zero crossings. As it is a cubic polynomial, if I try to equate this one, this y value equals to 0, how many values I am going to get for x? How many values I am going to get? Maximum I can get 3 values. Okay, I am going to get 3 roots. I am going to get 3 values of x where the y value is becoming 0 at maximum, right? Yes. This is what meant by zero crossing. And coming to the extrema, if I try to take the derivative, f dash of x is equals to 0. So what we are going to get here, 3 into a naught x square plus 2 into a1x plus a2. Okay, so for maxima or minima, in order to find extreme values, either it may be maxima or minima, what we need to do? We need to make this f dash of x is equals to 0. Isn't it or not? Right. So if I try to equate this equation is equals to 0, how many values of x I am going to get? How many values of x I will get? 2 values, right? 2 values. That means at these 2 values, I may have maxima or I may have minima, but I may not have extrema also. But actually, these are the stationary points. At maximum, how many I am going to get? 2, right? With these clues, try to tell me the answer here. Now try to tell me the answer. Yes, cannot have more than 2 extrema. Cannot have more than 2 extrema because see, f dash of x is having highest power as 2. So it cannot have more than 2 extremas. Right? Coming to the next one. And cannot have more than 3 zero crossings because the function itself is having highest power as 3. So it cannot have more than 3 extrema. So what is the correct option? C. Saloni, C is correct. Rambabu, C is correct. Lasya, C is correct. Perfect. Kanakasujini, maximum 2 extrema, 3 zero crossing. Right. Perfect. I hope it is clear, guys, for everyone. Please respond. I hope it is clear. Can I move to the next question? Come on, guys. Is this concept clear? I am expecting replies, guys. Is it clear? Can I move to the next question? Yes, okay. Yeah, see the next question. This is very small question, we can say, a very basic question. If A bar and B bar are 2 arbitrary vectors with magnitudes A and B respectively, then magnitude of A bar plus B bar whole square equals to. Everyone can answer this question. Everyone. Yeah, come on, Arpit. Try to answer this question. Very, very easy question. A very basic question. A very fundamental question, this one. Yes. Try to solve this question here. Try to solve this question. Simply we need magnitude of A bar plus B bar whole square. What are the basics required for this question? What are the basics? We know dot product of 2 vectors A bar dot B bar is equals to magnitude of A vector, magnitude of B vector and cos of angle between them. We know very well A bar dot B bar is AB cos theta. At the same time, A bar plus B bar is equals to magnitude of A into magnitude of B into sine of angle between them, and it is a vector in the direction of, it is in the normal to the A and B. So that's why we have to represent into n bar, because A cross B result is going to be a vector. So but what we need magnitude for this one. So the magnitude of A bar plus B bar is equals to AB sin theta. AB sin theta, right? So A bar dot B bar, the result itself is scalar, so that's why we need not to take any magnitude portion, right? The result itself is scalar, right? With these clues, please tell me the answer. With these clues, tell me the answer, guys. Yeah, Arpit, perfect. A is correct. A is correct. Just what we need to do is, let me take A bar dot B bar whole square plus A bar plus B bar whole square. Okay, so that what we are going to get here, we are going to get A square B square cos square theta plus the second one, A square B square sin square theta. I hope it is clear for all of you guys. Simply I have taken sum of their squares, okay, so that it is going to become A square B square into cos square theta plus sin square theta is equals to 1. Okay, so now with that what we need here, we need magnitude of A bar plus B bar whole square. Okay, that means we need this portion only. We need this portion only. So what will be the answer here? A square b square minus a bar dot b bar whole square. Yes, answer A is correct answer. This is a very basic question, guys. Is it clear for all of you? Is it clear? Yes. Okay, Shekhar. Yeah. Let us move on to the next question, which is one more basic question. It is just a property. This is just a property of eigenvalues. The diagonal elements of a 3 by 3 matrix are minus 10, 5, 0 respectively. If two of its eigenvalues are minus 15 each, then the third eigenvalue. Very, very basic question. Very basic question. A fundamental question of eigenvalues, we can say. A fundamental question from eigenvalues, we can say. I need answer for this, guys. Everyone's supposed to answer this question. Such kind of easy question, this one. Yes. Yeah, but we need to know Arpit. Yes, very easy question, right? Yeah. So what is the property behind this question? What is the property? The diagonal elements. See, we are having one property which is sum of diagonal elements is equals to, that means trace. Okay, sum of eigenvalues is equals to trace. Sum of eigenvalues is equals to trace. Trace means sum of diagonal elements only. So what are the diagonal elements here? Minus 10, 5, 0. Okay, and eigenvalues are minus 15 given. We don't know the third eigenvalue. So simply lambda 3 is equals to minus 5 plus 30. We can say 25, right? I hope this is 25. Very easy question, this one. Yes. Arpit, what is the answer here? Diagonal elements, trace is equals to minus 5. Here this is minus 30. Okay, that means plus 25 only supposed to be there. Yes, Arpit. Now you are correct. Yes. Right. I hope it is clear. So let us try to solve next question. This is a very good conceptual question. We need to be little bit patient to understand this question. But give it a try, guys. Give it a try. A very good conceptual question. In fact, we can play with this. A fair die with faces 1, 2, 3, 4, 5, 6, right? Thrown repeatedly till 3 is observed. That means we need to throw the die repeatedly until we are going to get 3. For the first time. Okay, that means we can stop throwing the die if we get 3. Here. That x denotes the number of times the die thrown and the expected value of x. Okay, here x is given some number of times dice thrown. Okay, and we need to find expectation of this x. Right? Expectation of this x. What is the expectation here? Okay, so ultimately we are going to use the formula of expectation only. At the end we are going to use the formula of expectation only, but we need data. To get this expectation. Give it a try, guys. Any answers? Yeah, so let me solve this one. Actually, what is our target? We have to, that means someone given punishment that we should throw die multiple times until we get 3. Fortunately, that 3 may come in the first trial itself, or it may come in the second trial itself, or it may come in the third trial itself, or it may come in the nth time itself, right? We don't know. That depends upon our luck. But actually, we should try to throw the die until we are going to get 3 here. That means if we get 3, then we can stop throwing. If we don't get 3, we have to do it again and again. So first of all, let me write the probability for getting 3. What is the probability of getting a 3 value if someone throws a die? Die is going to have total 6 outputs that are written here, 1, 2, 3, 4, 5, 6. That means the total number of possibilities are 6. Okay, in that probability of getting 3 is 1 by 6. Okay, probability of not getting 3, I am writing as P of 3 bar. Except 3, whatever the number we are getting, that is P of 3 bar only. It may be 1 or 2 or 4 or 5 or 6. Total how many possibilities? 5 possibilities are there. So P of 5 by 6. P of 5 by 6, right? So let me erase this. Yeah. Now what we are going to do? We are going to throw a die until we are going to get the 3. Okay. Let me take, I have thrown a die for the first time and I got 3 itself. For the first time itself I got 3. That's fine. We are going to stop. Next time. First time I didn't get 3. P of 3 bar. Second time I may get 3. Second time I may get 3. If I am getting 3, I will stop. Is it clear, guys? I am taking a die and I am throwing it and I am finding the value. If it is 3, I am going to stop. If it is not 3, I am supposed to repeat the same procedure until we get 3. Next. First time I didn't get it. Second time also I didn't get it. This time, third time I got the value of 3. Third time I got the value of 3. This process repeats. This process repeats. I may get value. If I get 3 value in the first instant, then the number of times of dice thrown will be 1. Because if I am getting 3 value in the first throw itself, then I am going to stop here. Then how many number of times I am throwing? 1 time only, because first time itself I am getting 3 here. If I am getting second time 3, then number of times I am throwing is 2. Similarly for 3. Similarly for 4. For 4, we are going to have P of 3 bar 3 times, and the fourth one is going to be the 3. Fourth one is going to be the 3. Right? Actually, what we have prepared is, we have prepared a table. Okay? This is X and this is P of X. Okay? Actually, this is written in indirect form. So P of 3, how much? 1 by 6. Right? This is what? P of X. P of 3 bar into P of 3, 5 by 6 into 1 by 6. Similarly, the third one, 5 by 6 whole square into 1 by 6. The fourth one is going to be 5 by 6 whole cube into 1 by 6. And this process will continuous, keep on going. Because we don't know when we are going to get the value 3 in the die. So, finally we got the table and we need to find expected value. What is the formula for expectation? What is the formula for expectation? As this is discrete case, the expectation is equals to sigma x into P of X. Sigma x into P of X. Simply x into P of X. X into P of X. X into P of X. So how much it would be? 1 into the probability 1 by 6 plus 2 into 5 by 6 into 1 by 6 plus 3 into 5 by 6 whole square into 1 by 6 plus and so on. This is what the expectation. So in all the terms 1 by 6 is going to be common because we are going to stop the process when we got the 3. So let me take 1 by 6 as common. So what we are going to get here? 1 plus 2 into 5 by 6 plus 3 into 5 by 6 whole square plus and so on. Right? Plus and so on. Yes. Now try to tell me which form it is. Which form it is? It is having one formula. Yes. Correct. 6 is correct. Kartikeya. Hi Kartikeya. Yes, 6 is correct. Come on Arpit, Sujani. What is the answer here? What is the form that is having here on this board? This complete one. 1 plus 2 into x plus 3 into x square plus 4 into x cube and so on. It is of the form 1 minus x whole power minus 2. 1 minus x whole power minus 2, right? So here in the form of x, in place of x, we are having one value which is 5 by 6. We are having the value 5 by 6, right? So try to simplify and try to Tell me the answer. Arpit, what happened? AGP. Yes, GP, correct. No, it is not GP. This is 1 minus x whole power minus 2. 1 minus x whole power minus 2. AGP means actually, yes, AGP, correct. AGP, correct. Okay, so what is the answer here? What is the answer? This is 1 by 6 into 1 by 6 whole power minus 2. That means 1 by 6 whole inverse, that means 6. So if I throw the die for 6 times, I can expect one value of 3. That is what the meaning of this complete question. What is the expectation here? See here, what is the question? If a fair die with faces thrown repeatedly till 3 is observed, okay, then the expected value, that means how many number of times we should throw to get the value of 3 for the first time is 6 times. That is what the meaning of this complete question. I hope it is clear for everyone. I hope it is clear for everyone. Arpit, is it clear? Karthikeya, is it clear? Can I move to the next question? Can I move to the next question? You may reply, guys. Yes. Next question. Try to solve this one here. This is also very easy and basic question only. I hope this question is visible. So let me write here. We are given with R bar x ax cap plus y ay cap plus z az cap. Okay. So the magnitude of R bar is given as R, and we need to find divergence of R square into del of ln r. This is a very simple question. We need to know only one single formula. We need to know only one single formula. If we know that formula, we can solve this one just like that. Just like that. Tell me the answer, guys. Tell me the answer. Come on, guys. Very easy question. Very easy question. First of all, what is the formula that we should know? What is the formula that we should know is this one. Let me write the formula here so that you can solve easily. Del of f of r is equals to f dash of r into del r. Okay. So one more thing I will write, del r is equals to r bar by r. R bar by r. Right? Right. Apply, use these formulas and tell me the answer here. Use these two formulas and tell me the answer. Yes, Arpit, 3 is correct. 3 is correct. See here, del of ln r is going to be 1 by r into del r, right? Whole bracket into r square, and again we need to find divergence also. See here, what is del r here? R bar by r square, right? So again here we are having one more 1 by r into r square. So this r square will get cancelled. So we are going to remain with simple r bar only. So divergence of r bar is equals to 3. This is one more important property. This is one more important property. I hope this is clear. I hope this is clear for everyone. Because very basic question. Just we need to know these two formulas. Is it clear, guys? Remaining guys, is it clear? Yes, Rambabu, 3 is correct. Nice. Is it clear for everyone? Yes. Let me move on to the next question. This one. This is also very basic question. This is also very basic question, we can say. A very basic question, we can say. Try to solve this one. Try to solve this one. It's an easy question, but we can say the answer without solving and all. Without solving and all, we can say the answer just like that. Tell me the answer, guys. We need not to solve anything. Just like that, we can tell the answer. The number of solutions of the simultaneous algebraic equations y is equals to 3x plus 3 and y is equals to 3x plus 5. These are the equations that are given, right? These are the equations that are given. Now he is asking the number of solutions of the equations. Number of solutions. 0, 1, 2, infinite. Yes, 0. Because everyone knows. Everyone knows. If you try to see here, y is equals to 3x plus 3 and y is equals to 3x plus 5, both the lines are having some relation. What kind of lines they are? What kind of lines they are? We need reason, guys. We need reason. We need reason. If we know the reason, then we can solve any kind of questions. Yes, option A is correct. Option A is correct. When we take in two equations, either those two equations may be parallel to each other, okay, or may they supposed to intersect at one point, or they both lines represent only one line, okay. Those three cases only will come. Those three cases only will come, right? If I take simple graph here, yeah, if you take the graph here, yeah, if I try to take two lines for suppose, yeah, let me change the color. If I take two lines, okay, those two lines supposed to intersect one point. If two lines are intersecting at one particular point, then we can say this is having unique solution. Unique solution, okay. This is the one case. Other case, if two lines are parallel, two parallel lines are never going to intersect at any cost, so it is not going to have any solution. It is not going to have any solution. Sometimes the equations looks like two, but they will represent only one line. They will represent only one line. At that case, we are going to get infinite number of solutions. We are going to get infinite number of solutions, right? These are the three possible cases for the solution of linear equations. Solution of linear equation. So yes, purposing parallel lines is correct option. So parallel lines are never going to intersect at any point. That's why we are not going to find any solution or any point of intersection for these two lines. So of course, no solution we can say. Okay, we can say no solution, so that the number of solutions also 0, right? I think it is clear for everyone. Yes. See here, this is a very good conceptual question. We need to solve this one. Give it a try, guys. Give it a try. It is based on the movements. It is based on the movements. The first movement, second movement, third movement and all. From where they are going to get? We are going to get from movement generating function. Movement generating function. See here, the second movement of a Poisson distribution random variable is 2. Here the second movement is given. And he is asking about the mean value. He is asking about the mean value. Mean value. Any answers, guys? A very good conceptual question. Second movement value is given, and we are asking to find the value of mean. Try this question, guys. No? Give it a try, guys. Give it a try. First of all, what is meant by moment generating function? What is meant by moment generating function? Moment generating function we can write as mx of t as expectation of e of xt. E of xt. Right? E of xt. E of xt. So all of us know what is the e power x formula. What is the e power x expansion? This is going to become 1 plus x by 1 factorial. X by 1 factorial plus x square by 2 factorial, right? And so on and so on. So try to apply expectation here. So what we are going to get here, we are going to get 1 plus t by 1 factorial into expectation of 1 plus t square by 2 factorial into expectation of x square, and so on and so on. Okay, here we are going to take this one as first moment m1. Okay, here we are going to take this e of x square as second moment m2. Okay, now that is what given in the question. The second moment of a Poisson distributed random variable is 2. Now tell me the answer, guys. Now tell me the answer, guys. Arpit, Saloni, Lasya, come on. What is the answer? It's a very good question. It's a very good question. What is given here? Second moment is given. Second moment is given as 2. Second moment is given as 2. E of x square value is given as 2. Okay, in Poisson distribution there is only one variable, that is what lambda. That is what lambda, which is equals to mean, and this one is also equals to variance also. Mean and variance both are same. Mean and variance both are same in Poisson distribution, which is equals to lambda. Okay, so let me write variance. Let me write variance formula here. Expectation of x square minus expectation of x whole square. Expectation of x whole square. Okay, mean means expectation of x, we can say, which is lambda, so variance also lambda. So this one is going to be lambda is equals to expectation of x square minus expectation of x. How much this is mean? Expectation of x means mean only, right? How much the mean value? How much? Lambda. So expectation of x square is equals to lambda plus lambda square. Lambda plus lambda square. This is what second moment. And this one is given as 2. This one is given as 2. And what is asking in the question? Which one we have to find here? The mean. That means we have to find the value of lambda. We have to find the value of lambda here. We need to find what is the mean value. We need to find what is the value of mean here. Any answer, guys? Any answers? Any answers for this question? We have solved everything. Yes. Just we need to find the value of lambda here. Tell me what is the value of lambda, guys? We have solved everything. We have done everything. We have seen what is meant by moment generating function, what is meant by second moment. We have derived the formula for second moment, and we are trying to find the mean value, that is which is nothing but lambda. Yes, Arpit, one is correct. One is correct. Lambda square plus lambda minus 2 is equals to 0. Here little bit tricky part is also there, because we are going to have two values for lambda here. We are going to have two values of lambda, right? So those are lambda square plus 2 lambda minus 2 is equals to 0. This is what we can write, lambda into lambda plus 2 minus 1 into lambda plus 2 is equals to 0. So this one we can write lambda plus 2 into lambda minus 1 is equals to 0. Okay, so lambda is equals to 1, and at the same time we can write lambda is minus 2. Among these two, which one we have to take? Which one we have to take among these two? Lambda is equals to 1 and lambda is equals to minus 2. Never ever we are going to get negative value here. Never ever. In Poisson distribution. In Poisson distribution, minus 2 should not be taken, right? Yes, Kartikeya, correct. Yes, Lasya, both the values we are going to get, but one is the correct answer. One is the correct answer. Arpit, one is correct answer. Yes, I hope this concept is clear for everyone. Is it clear, guys? Is it clear, guys? Is it clear? Any doubts on this question? Any doubts? Yes, Saloni, right. Lasya, right. So let us move on to the next question. Yes, Rajmohan, right. Let us move on to the next question. See here, this is also very easy question, we can say. E power z is periodic with a period of. E power z is a periodic with period of. Here we need to find the period of the function e power z. Simple question, very, very simple question. I am expecting answers for this one from everyone. From everyone. A very basic question. Give your answer, guys. Give your answer. Arpit, what is the answer for this one? A very basic and easy question. A very basic and easy question. Come on, guys. Come on, guys. What is the answer for this? Here, e power z is a periodic with period. It is provided that e power z is already periodic function. So let me take this function as f of z. E power z as f of z. F of z. What is meant by period? First of all, if you are able to write a function f of x as f of x plus t, f of x plus t, then we can call this t is a period of this function. This t is a period of this function, right? Based on this one, we need to find a value which is equals to f of z is equals to f of z plus t. We need to find a value of t which is equals to f of z plus t. F of z plus t equals to f of z. Such kind of value we need. This t from this one of the option. Yes. So let me try to expand. This e power z as e power x plus iy. X plus iy, right? Here z is a complex number, right? Z is a complex number. So if I try to write this one as e power x into e power iy, e power x into e power iy, e power x into e power iy, we are going to get e power x into this one e power I theta, we can write as cos theta plus I sin theta format. Okay, e power iy, we can write cos y plus I sin y. Cos y plus I sin y we can write, right? Yes. Now what I am going to do here, I am going to write this cos y as y plus 2 pi, and here similarly sin also sin y plus 2y, sin y plus 2y, right? We can write like this: 2 pi plus theta is going to be again cos theta only, 2 pi plus theta is going to be, or 2 pi plus y is equals to again sin y only. So I am writing this one as e power x into again cos theta plus I sin theta, or cos x plus cos something plus I sin something. We can write e power again I into y plus 2y. Again I came back to the original form, e power I theta form, right? So this is going to become e power x plus iy plus 2 pi I. So again I am rewriting this x plus iy as z, so that we are going to get z plus 2 pi I. So this is what equals to e power z, because we have taken e power z only. We have taken e power z only. So this is what represents f of z is equals to f of z plus t. This t is nothing but period. So what is the period here? 2 pi I. 2 pi I, right? So that is the answer here. Yeah, 2 pi I. B is the correct option. Is this clear, guys, for everyone? Is this clear? Arpit, B is correct. Rai Mohan, B is correct. How why? 2 pi is correct. TN, B is correct. Perfect. For remaining guys, is it clear? Is it clear, guys? Shall we move to next question? Is it clear, guys? Yes, clear. Yeah. The next question. This is also a very beautiful conceptual question. A very beautiful conceptual question, this one. Try to solve this one, guys. A very good conceptual question. Yes, Saloni. Try to solve this question. Where 20% managers are technocrats. 20% managers are technocrats. The probability that a random committee of 5 managers consisting of exactly 2 technocrats is. Try to solve this one, guys. At least tell me the idea. Tell me the idea. How we have to solve this one? How we have to solve this one? Tell me that. Give me the idea. Just give me the idea. Just give me the idea. How to solve this question? Give me the idea. Here it is mentioned that 20% managers are technocrats. Okay? We are going to form a committee of 5 managers consisting of exactly 2 technocrats. Exactly 2 technocrats. What is the answer, guys? What is the answer? Arpit, what is the answer? What is the answer, guys? Any answers? Yeah, let me solve this one. First of all, actually there are some number of managers are there. Few number of managers are there. Among them, 20% are technocrats. Okay, what about remaining 80%? What about remaining 80%? We don't know. We don't know. They are not technocrats. That is what we know. That is what we don't know. But they are not technocrats. Okay, is it clear? First of all, so let me find this 20%. 20%. How much we can say this one? 1 by 5. 1 by 5. Right? So not becoming technocrat is going to be 4 by 5. 4 by 5. Is it clear? First of all, is it clear? 20% managers are technocrats. Okay, 20% are technocrats. 80% are non-technocrats. Right? Yes. Okay. So with this one, what is the actual probability that we need to find? We need to form a random committee of 5 managers. And there are exactly 2 technocrats. Exactly 2 technocrats. See, we are going to form a committee of 5 members. 5 members. Among them, 2 should be technocrats. Remaining 3 non-technocrats. Non-technocrats. Okay. First of all, which probability distribution we have to apply? Which one we have to take? Which distribution we have to take? First, tell me this. Tell me that one. Is it binomial or Poisson? Which one we have to take? Which one we have to take here? Which one we have to take? Which one we have to take here? We are going to take this n is equals to 5 as total number, and p of x is equals to 2 is going to be our favorable. And the random variable x that we are going to take as the number of technocrats. Okay, x we are going to take as technocrats. The number of technocrats we are going to take. Okay, so what is p of x equals to 2 meaning? The probability of getting exactly 2 technocrats out of 5 managers. So what is the formula here in binomial? NCR into p power r into q power n minus r. Right? Q power n minus r. That is what the thing. What is the p value? What is the q value here? We are clear with r, which is equals to 2, and we are clear with n, which is equals to 5. Okay, n value we are having, r value we are having. What about pq? Here p is probability of success we are going to take as p, which is 1 by 5, and q is 4 by 5. Now we are having all the values. N is there, r is there, pq, both are there. So try to find p of x is equals to r. Yes, Arpit, binomial is correct. Perfect, binomial is correct. Try to tell me the answer. Guys. Let me solve. Yeah, what is the n value here? 5c2 into p value how much? 1 by 5 whole square into 4 by 5 whole cube. Right? So 5ct we can write as 5 into 4 divided by 1 into 2 into this one we can write 1 by 5, 1 by 25 you can write, into this one we can write 4 into 4 into 4 divided by 5 cube we can write directly to 125. Right? Try to solve the answer, guys. That's it. Yes, Prasad, A is correct. Saloni, A is correct. Remaining guys, come on. What is the answer? How much we are going to get here by simplifying this one? Let me see. What is A here? Yeah. I don't have calculator. Just tell me the answer, guys. Just tell me the answer for this one. Yeah, we may get A only 0.2048. Is it clear for everyone? Yes, A is correct only. Now let me give a try. This one 2 2 0, and we are going to get this one 5. Yeah, we will get, I think. Yes, perfect. 0.2048. Is it clear, guys? Is it clear? Is it clear, guys? Any doubts from this question? Any doubts? The concept is very clear. We need to understand the question properly. That's it. We need to understand the question properly. Shekhar, good. Lasya, good. What about remaining guys? Shall we move to next question? Yeah. This is also good question. From maxima minima. Try to solve this one, guys. Try to solve this one. Right. Try to solve this one. The range of values of k for which the function has a local maxima. Yes. Right, Shekhar? Try to solve the next question. The range of values of k for which the function has a local maxima. First of all, what is the concept behind this? We are going to have the value of f of x here. We are given with f of x, and we need to find f dash of x for maxima or minima, and we should make it equals to 0 for maxima or minima. After that, we need to find f double dash of x also. Okay, what is the condition given in the question? It should have a local maxima. In order to have local maxima, what should this value? What should be this value? F double dash of x. In order to have local maxima at x is equals to 0, this should be equals to less than 0. This is less than 0. Is it clear, guys? Is it clear? So let me try to take this one. Function f of x is equals to k square minus 4 into x square plus 6x cube plus 8x power 4. Okay, right? So let me take f dash of x here, which is 2 into k square minus 4 into x plus this one 18x square plus 32x cube, right? Right. What is f double dash of x here? This is equals to 2 into k square minus 4, okay, plus this is 36x plus this is 96x square. Okay, right? What should be the f double dash of x? Should be less than 0 to get local maxima. Is it clear, guys? Is it clear? Try to apply this concept. Try to equate this one. Try to make it less than 0 and tell me the answer. What is the answer for this one? In order to have local maxima, f double dash of x should be less than 0 at that point, right? Yeah, it is given that at x is equals to 2, sorry, at x equals to 0, what is the value of f double dash of 0? Right? So this is going to become 2 into k square minus 4 plus 0 plus 0 plus 0 plus 0. Right? So ultimately this is 2 into k square minus 4 should be less than 0. Okay? Now tell me, guys, what is the answer? Now tell me what is the answer. I hope it is clear, I think. As of now it is clear, I think. We have seen the concept and we have applied and we got the answer. What is the answer, guys? What is the answer for this one? Yeah, it's done. So the k value should be lies between minus 2 to plus 2, so that then only k square minus 4 will become less than 0. Okay. So option C is the right option. I hope this is clear for everyone. Yes, Jayesh Patel, yes, correct. Rasya, C is correct. Yeah, let me move on to the next question. This is also a very good question based on Lagrange's mean value theorem. Try to solve this one, guys. Try to solve this one. The Lagrange's mean value theorem is satisfied for the function satisfied for the function f of x is equals to x cube plus 5. F of x equals to x cube plus 5 in the interval 1 comma 4. In the interval 1 comma 4. At a value. That means we need a value of x in the interval 1 comma 4. In the interval 1 comma 4, which satisfies the Lagrange's mean value theorem. The Lagrange mean value theorem. Lagrange mean value theorem. In order to apply this theorem, in order to find that value of x, we should know first of all what is Lagrange's theorem. What is Lagrange's theorem? Give it a try, guys. Give it a try. What is the value of x here? What is the value of x? What is Lagrange's mean value theorem means? If we are having function f of x, it should be continuous in a closed interval a comma b, okay, and it should be differentiable in open a comma b. Then there exists a point c. We can say there exists at least one point c such that f dash of c is equals to f of b minus f of a by b minus a. F dash of c is equals to f of b minus f of a by b minus a. There exists at least one such kind of c for such kind of function. Okay, so we need to find such c only now, as of now, right? So try to apply this formula and try to find the value of x. Try to find the value of x. Here f of x is given, okay? Here a value, b value both are given. A, b both are given. Here the formula also given. What else required? Find the value of c here. Find the value of c. Find the value of c. What is the answer, guys? What is the answer? So let me try to find, first of all, what is f of b here? F of b, which is nothing but f of 4. F of 4. How much it would be? F of 4. 4 cube plus 5. Right? Similarly, what is f of a here? F of a. F of a is equals to f of 1, which is 1 cube plus 5. 1 cube plus 5. Okay. F of 4 minus f of 1. How much it will be? Okay. 4 cube minus 1. 4 cube minus 1. Right? What is the b minus a value here? B minus a is equals to 4 minus 1, which is equals to 3. Which is equals to 3. Right? Next. As we are having f of x, what is the value of f dash of x here? Which is 3x square, simply. So what is f dash of c here? 3c square. Okay, so we got all the terms here. We got all the terms. Just form an equation and tell me the answer. 3c square is equals to, based on this formula, f of b minus f of a, we are going to get 63 divided by 3. 63 divided by 3, right? See here, f of b minus f of a, f of 4 minus f of 1, 64 minus 1, 63, and b minus a is 3, right? So this one 21, and 3c square equals to 21, c square is equals to 7, c square equals to 7, c is equals to plus or minus root 7, plus or minus root 7. But we need a value, that should be in the interval 1 comma 4, should be 1 comma 4, 1 comma 4. That means plus root 7 minus root 7. This one we are going to eliminate. This one we are going to eliminate because minus root 7 is not in the interval 1 comma 4, 1 comma 4, right? 1 comma 4. Yes, root 7 is the correct answer. Plus root 7. Yes, plus 2.64 is correct option. Is it clear, guys? Is it clear? Any doubts on this question? Any doubt? Shall we move to the next? Yes. This one is a very good conceptual question. Try to solve this one. At x equals to 0, the function x cube plus 1 has either it is having maximum value or minimum value, singularity or point of inflection. Singularity or point of inflection. That we should say. That we should say. Maximum or minimum, singularity or point of inflection. Tell me guys, what is the function given? F of x is equals to x cube plus 1. Sorry. F of x is equals to x cube plus 1, right? Our discussion is at a point x is equals to 0. Our discussion is at a point x is equals to 0. At x is equals to 0, this function is having maximum value or minimum value or singularity or point of inflection or point of inflection. Tell me guys, what is the answer? What is the answer for this one? In order to know, first of all, we should equate f dash of x is equals to 0. F dash of x equals to 0, right? So if I try to equate, what we are going to get? We are going to get 3x square is equals to 0. That means we are going to get x is equals to 0. X is equals to 0. Okay, our discussion is also about a point x is equals to 0 only. X equals to 0 only. So we have to, in order to say maxima or minima, in order to decide it is having maximum value at x equals to 0 or minimum value at x equals to 0, we should find f double dash of x. We should find f double dash of x. What is f double dash of x here? This is going to become 6x, 6x. Okay, our discussion is at a point x is equals to 0. X is equals to 0. So f double dash of 0, f double dash of 0 is equals to 6 into 0 is equals to 0. If f double dash of x is less than 0, we can say something. Greater than 0, we can say something. Is equals to 0, what we have to say? If f double dash of x is less than 0, we can say it is having maximum value at x equals to 0. If f double dash of x is greater than 0, then we can say it is having minimum value at x equals to 0. But instead of that, f double dash of x is equals to 0 at x equals to 0. Then what we can say is, we can say it is a point of inflection. It is a point of inflection. Point of inflection is a point where the function is going to change its shape from concave up to concave down or concave down to concave up, we can say. Okay, so whenever we are finding such kind of situation that f double dash of x is equals to 0 at particular point, then we can say that point is point of inflection. Point of inflection. Yes, point of inflection is correct, Lasya. Yeah, is it clear guys? All of you, is it clear? Shall we move on to the next question? Yes, D is correct, Saloni. Let us move on to the next question. Try to solve this one. We know this one is a Fourier series question. We know very well. But we can solve this question just like that. Just like that. Within 30 seconds we can solve. Even 30 seconds is also more, we can say. Give it a try guys. Give it a try. The Fourier cosine series for the function f of x. Right? The Fourier cosine series is given here. F of x is equals to a0 plus summation of an cos nx. The value of coefficient a2 we need for the function f of x. F of x, which is equals to cos square x in the interval 0 to pi. Okay, Fourier cosine series. That means we need to find the value of a0, the value of a2. Sorry, the value of an, because we need the value of a2 here. We need the value of a2. That means we need to find an, and after that we need to substitute n is equals to 2 in order to get a2. Okay. Is it required? First of all, do we need to find an in order to say the value of a2? Give me reply guys. Give me reply guys. Do we need to find a2? Do we need to find an? Or directly can we say the answer? Do we need to find an? I hope all of you know an is going to have the formula like 1 by pi integral 0 to pi f of x into cos nx dx and all. Do we need to find an? do we need to find an in order to find a2? Tell me the answer, guys. Tell me. Can we say directly, or do we need to find an? That is the question here. By applying a simple logic, we can get the answer for this one easily, very easily. We can get the answer for this one just like that. 10 seconds also not required. Come on, guys, reply this question. Very beautiful question. Just like that we can answer. How you guys are saying 0.5? How you guys are saying 0.5? Yes, we can say, we can write directly this cos square x as, we can write directly this cos square x as 1 plus cos 2x by 2, 1 plus cos 2x by 2, by using cos 2x formula. Cos 2x is equals to 2 cos square x minus 1. From that we can write directly cos square x is equals to 1 plus cos 2x by 2, cos 2x by 2. So directly we are going to get the coefficient, we are going to get the coefficient which is of the form, 1 by 2 plus 1 by 2 into cos 2x, as it is written cos nx here, an into cos nx. So this is cos 2x and this is a2, okay. Directly this is 0.5, right? We need not to find anything. Whenever we are able to, yes, we can find directly, find a2, correct, right? Whenever we are having the form which is directly comparable with Fourier series expansion, we need not to find, okay. For that one we should need a trigonometric functions in different multiples, in different integral multiples, like see this one cos 2x, cos 3x. Whenever we are having such kind of expressions with us, then we need not to find a1, a2, an, bn and all. Directly we can say 1 plus cos 2x by 2. By using that we can say 1 by 2 is the coefficient of cos 2x. From that one we can say the answer is a2, right? Any doubts? Any doubts, guys? Any doubts? Any doubts from this? Any doubts? Is it clear for everyone? Is it clear for everyone? Is it clear? For remaining guys, is it clear, guys? Yeah, thank you Ram Babu. Yeah, okay, nice, Shekhar. So that's it for today. We are going to end this session. Thank you guys, thank you so much for watching. Try to share, like, subscribe to Gate Conqueror. Thank you so much. Good night all.